Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to wiring the 4Y and 2Y connection of PLC S7-300 to the temperature transmitter. There are two types in this section. The first one is temperature transmitter use 4Y analog input connect to the PLC S7-300 Analog module. Okay, and one more for temperature transmitter 2Y that I already connect with thermocouple and then connect to the analog input of PLC S7-300 also. Okay, and in this section I will explain step by step about how to configuration and test for hardware configuration, yes, by using the SIMATIC Manager and WinCC Flexible to create the project and then download to the HMI. Okay, so before go to software, I would like to explain a little bit about how to wiring and how to selection the hardware configuration of this module. Okay, because it's very important the hardware configuration and wiring, otherwise we cannot testing with the PLC module if we cannot wiring. Okay, so let's go to wiring. So first I would like to explain about how to wiring. Okay, here is the analog module of PLC S7-300 SM311 7KF02 0AB0. Okay, and here is the terminal connection. There are 20 terminals. The terminal number 1 we will connect the 24 voltage plus, and for terminal number 20 we will connect minus or 0 volt DC to this terminal. Okay, and if we would like to connect the PT100, we can select PT100, or another channel we can select 0 to 10 volt DC input. And for terminal number 12 and number 13, I already connected the 4Y transmitter, yes, from this one, yes, from this one temperature transmitter 2Y to this module. Okay, with the terminal 13 and 12. Okay, for terminal 12 we will connect milliamp plus, and terminal 13 we will connect minus to this terminal. Okay, so this is the connection for Y transmitter. And for 2Y transmitter we can also connect with the transmitter, yeah, another transmitter, example pressure transmitter, temperature transmitter, flow transmitter that use 2Y, so we can connect like this. So first we connect the terminal 16, it is the plus, yeah, the positive milliamp. If we send the hardware configuration here like this, okay, if we select the hardware configuration here to be D, yeah, D, it means that 2Y, yeah, here selection to D, it means that 2Y, it will provide the terminal, yes, the terminal 16 and 17 is 24 volt DC. Okay, so if we select to D, the PLC analog module terminal number 16 and 17 will provide 24 voltage to the transmitter, okay, to Y transmitter. So we can connect to 17 to plus, 16 to positive, yes, and then we will connect the thermocouple signal to the transmitter, so we can got the raw value. Okay, so this is very important for this connection. So terminal number 14 and 15 we can also use with 4Y, and terminal 18 and 19 we can also use the 2Y connection. Okay, so I hope everyone will understand about how to connect like this. So please follow my connection, otherwise we cannot test with the module. Okay, so let's back to our slide. So here is the analog input module that I already connected the cable milliamp from temperature transmitter 4Y and temperature transmitter 2Y here. Okay, so it will follow the selection. So here is the selection for channel number 1 and number 0. I will select to A. It means that PT100 signal directly. We can connect the PT100 directly to this module. And for channel number 2 and number 3, I already select to B. Yeah, it means that 0 to 10 volt or 0 to 2.5 volt, 0 to 5 volt DC signal, yes. And for channel number 4 and number 5, I select to 4Y current, 4 to 20 milliamp. And for channel number 6 and number 7, I already select to 2Y current, 4 to 20 milliamp also. Okay, so the selection and wiring is very important, yes. So let's go to our software to create the hardware configuration and project to download to the PLC. Okay, so first let's open SIMATIC Manager. Okay, and then I will create a new folder. 2Y and 4Y. Okay, then create the new project. Yes, so browse to find the folder that we already created here, and this example analog input connection. I hope it so far so long, right? Example connection, yes. So click OK, and then go to create the new object for SIMATIC 300 station, and go to the hardware configuration, and then go to SIMATIC 300 and go to Rack, insert the rail to the project, and then choose the CPU type Right now I already use the CPU 314C 2PN/DP. Yes, here. Drag and drop. And here is the IP address of PLC, so we no need to change anything. Just click OK. And then I have one more module, right, for analog input module. So let's go to SM300, AI300, and then let's choose the module that match with our hardware. So right now I will use ES7 ES7-300 7KF02 0AB0. Okay, so drag and drop, and then we need to select the selection right here. So first we need to select the input type, measuring type, follow our selection here. Yes. If the input type select to A, so we need to select the software to be PT100 or some millivolt. Yes. So right now I will select to PT100, and for channel number 2 and number 3 I will select to 10 volt because select to B, and for channel number 4 and number 5 I will select 2Y, sorry, 4Y, yes, because I select 2 C, right? C, it means that 4Y, to 4 to 20 milliamp. And for channel number 6 and number 7, I will select 2Y, 4 to 20 milliamp also, okay? And the address will start from PIW 256, okay? And then let's save the project. And then we need to download the hardware configuration to the PLC, right? So before download, let's make sure the IP address of our computer is need to put the manual mode, okay? So the IP address of PLC the IP address of PLC is 192.168.0.1, right? And we need to put the IP address of our computer. Yeah, PC IP address is 192.168.0.253 or something that we can put, okay? Okay, so we need to put the manual IP address of our computer. Otherwise, we cannot ping, right? Example, I ping to 192.168.0.1. Cannot ping, right? Okay, so we need to put the manual IP address. And we make sure we need to turn off Windows Firewall, yes, like this. Otherwise, we cannot ping also, yes. Okay, so we can test for ping 192.168.0.1, okay. So it's so like this, it means that we can communication between our PC to the PLC, okay. Then we can go to set temporary set PG interface, yes. okay, here. And then go to hardware configuration again, and then click download. So wait a moment for detecting the PLC S7-300. It will detect automatically if it found the CPU. So wait a moment. CPU 314C 2PN/DP. Okay, right now it detects one CPU 314C 2PN/DP. Yes, and then we can click OK, and then click OK again to stop the CPU and then download. Okay, so right now we already download the hardware configuration to the PLC, and then we can go to show the status, go to monitor, modify variable. So it will start from okay, it will start from this address, right? So for the address, we can check on the hardware configuration. Here it will start from PIW256. Okay. So PIW256, PIW258, PIW260, PIW262, PIW264, PIW268, 66. So 1, 2, 3, 4, 5, 6, PIW268 and PIW270. Okay, so we can online for check, and we can show as decimal. Okay, so right now I already select and connected the transmitter, temperature transmitter for Y to this channel, and for 2Y I connect this channel. Okay, so we can show the actual value of temperature also by go to block and then create the block. Okay, example show the temperature of sensor 1. Okay, and then let's go to use the convert, right? So let's go to library, standard library, go to IEC or go to another block that we can use. Right now, right now we need convert the block by using the scale, right? Okay, so we can use the FC105. So for sensor number 1, we can use address PIW264. Yeah, so PIW264. and we can mark edit symbol, and it is integer, right? So integer, and then we can comment address of sensor number 1. Okay, so for rank high scale, it means that engineering high unit, we can put another rank to match with our transmitter. So for my transmitter is ranked from 0 to 100 degrees Celsius, and this one I will use example 1.0. Okay, and here is the address. So example I will use MW 10, and this one I will use MD20. Yeah, example. So we can save the project and then download to the PLC, and then we will got the actual temperature. Yes, right now it's show around 23 degrees Celsius. Okay, I will add one more block, and then I will show the real status of this temperature. Okay, so let's create one more for sensor number 2. So I will offline first and then create the new example. This one we can remark like 4Y connection of transmitter. Okay, and insert one more network, example 2Y connection of transmitter. Okay, and then I will use FC 105 also. Okay, and we need to put the address of sensor number 2, right? So for sensor number 2, right now I connect to PIW26H. So I will use PIW26H, and we can edit symbol, and then the data type is integer, and then we can command sensor number 2. Okay, and for rank I will use 100 also for high scale, and low scale is 0.0 also, and here I will use M 1.1. Yes, and here I can use another address that not duplicate with this one. So I will use MW 40. Yes, something like this, and MD50. Yes, we can save the project and then download to the PLC. Yes, and then we can online. So right now it's so around 17 degrees Celsius, right? So the scale of this transmitter is 150.0 for high scale. Okay, then we can download, and also show around 26 degrees Celsius. Okay, so let's go to create the project of WinCC Flexible to show the actual temperature on the HMI, right? So first let's go to open the WinCC Flexible software and create the new project, and choose the correct HMI model that match with our HMI hardware. Yes. So right now I will use MP 27710 touch. Yes. And then create the new connection. Yes. So double click on new connection. So example PLC 1, or we can write HMI 1. And this is a communication driver that we will connect to. So I will choose SIMATIC S7-300 400. Yes. And I will use Ethernet connection. And here is the IP address of PC. So our PC is 192.168.0.253. So 192.168.0.253. And here is the IP address of PLC. So 192.168.0.1, 192.168.0.1. Okay. And we need to create the text, right? For text, we have two text for show on HMI. The first one is MD 20 for sensor number 1. Okay. So we can go to text tab and then choose the sensor 1 for Y. Yes. And the data type is real, right? So we can choose real and MD 20. Then we can command example actual temperature of sensor 1. And we need to insert one more for sensor number 2, right? And it is 2 Ys. Okay. And MD address is MD 50. So I will put this one MD 50. And we can command actual temperature of sensor 2. Okay. And then we need to insert the screen, right? Create the screen. For screen, I will use this color. Yeah. Go to property and I will change to this color. Yes, yellow color. And then I will insert the text. Example how to show the actual temperature. And then go to property and then go to text. I will go to center and then change to middle. For layout, we can choose the setting. Otherwise, we cannot adjust, right? So uncheck the auto sizing. So we can resize. and then we can go to the text again and choose the font size and modify the size that we want. Okay, so we can choose another color that we want, example red color, green color, or blue color, or this color. Yes, I will use this color. And for the text, we can adjust to be another color that we want. Example, I adjust to yellow. Yes. And we need to create the I/O file. Yes. Example for sensor number 1. It is the output, right? So take number 1 is sensor 1 for Y, right? Okay. This is the format. So we can adjust. And we can go to property to adjust the color of text and color of the background. Go to center and go to middle. Yes, actually we can adjust here like this or like this or like this. Yeah, that we want. Okay, if font size, we can also adjust here. Yes, just like this. So this is a sensor number 1. So we can copy from here and then change to sensor 1. Okay, sensor 1. Like this. And for the border, we can use also white color. Yes, like this. And for this color, I will change to white, and then we need to copy to 4 unit, right? Example degree Celsius. So we can copy, and this one we can adjust the size to be 9. So we can like this, and we can group also. Yes. So I will adjust this size to be 22. Okay. And for sensor number 2, we just copy like this. We will got sensor number 2. Yeah. And then change this one to sensor number 2. This one we can choose the take number 2. Yes. So we can save the project. I will save to desktop and then go to this one. Example project test. Okay. Actually, we can simulation before download to the actual, the real HMI. Yes. So we can simulation. Okay. So right now we got sensor number 1 is 23 and sensor number 2 is 27 degrees Celsius. Okay, so we can download to the HMI. Before download to the HMI, I would like to explain a little bit about how to check the IP address before we download. Otherwise, we cannot download, right? So let me show a bit before we download. So right now I will turn on the power of HMI. So wait a moment for turn on the power to HMI. Okay, it's booting the system. And then go to control panel. And then go to the transfer. Yeah, double click the transfer. And make sure we select the Ethernet because we would like to use the LAN cable. Download to the HMI, right? And go to property, go to advanced and then double click here. So we will show the IP address 192.168.0.10, right? Okay, click OK. And then go to OK. And then go to transfer setting. So we need to select this one to the advanced Ethernet also. Okay. Otherwise we cannot download. Okay. And then click OK. And then click close. And then click transfer. Yes, don't forget click transfer. So right now I will transfer the HMI project from my computer to the HMI. So we can click here, download. And here is the option that we can choose. So right now I will choose Ethernet and IP address 192.168.0.10, right? Click transfer to confirm. And click yes to confirm. Could not estimate connection. Please check your setting and cable. Okay, so we need to check the IP address again. Control panel again. Go to the transfer. Okay, Ethernet is correct. Okay, that's correct. Transfer again. So I will ping to the HMI first. So we can ping CMD ping 192.168.0.10. Cannot ping, right? So let me check the LAN cable again. Okay, so right now we can ping, yes, and then we try to download again. Okay, right now downloading, complete successfully, and then we will got the screen like this. So sensor number 1 around 23 degrees Celsius, sensor number 2 around 26. So let me hit the sensor. Let me hit the sensor. Okay, sensor number 2 start increase. Let me hit the sensor number 1. Okay, it start increase also. Yes. Okay. So for this temperature transmitter is 2Y and this temperature transmitter is 4Y. Okay. We can also simulation. Yeah, it is the same. Yeah. Simulation here and the screen is the same. Show the same. So here is just an example about how to connect the wiring for 2Y and 4Y connection to PLC S7-300 by using temperature transmitter. Okay. So thank you very much for watching my video. And if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also. And don't forget, click the bell to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today we will continue to part 48 and 3 to configuration the hardware between PLC GE to PLC S7-300 and to PLC S7-200 also by using the Profibus master of PLC GE linked with the Profibus slave of PLC S7-300 and also linked with the Profibus slave EM277 of PLC S7-200. Okay. So in the previous video, we already linked between the data between PLC GE and PLC S7-300, right? So in this section, I will add more type for S7-200. Okay. So let's go to see the how to configure, yes, and test with the actual, yes. So let's go. So first let's open existing project that we already learned in the previous video. So first let's configure the PROFIBUS Machine Edition hardware configuration. Yes, and we will use the existing project that we already learned in the previous video. So let's open the existing project. And let's go to Profibus master. Yeah, we will add more. Yeah, so the Profibus master is PNS3. So let's go. So to add the PLC S7-300 Profibus layout here, yes. First, we need to have the GSD file for EM277 Profibus layout. Yes. So right now I already put the GSD file here. Yes, here. If we don't have the GSD file, we cannot add the slave for Profibus, right? So to add this module, let right click here, Profibus master, and then add slave. And if we don't have the Profibus slave of PLC S7-300, let's create or click the have this, right? And then go to desktop to find the GSD file that we already keep on desktop here. Yes. So we will got the EM277 PROFIBUS-DP slave. Yeah. And then click OK. And here is the address that we will put. For this address, I already put number 5. So this address, I will put number 6. Yes. And we need to select this one. Yeah. To number 6 also. Yeah. We have H10 and H1. So first select H1 to number 6. Yeah. To match with our configuration. Yes. And for module, yes, we need to add right here. So let's click add. So first, for test this module, I will add for 8 byte out and 8 byte in. It means that 8 byte output and 8 byte input. Yes. And for parameter, we need to use the V memory, right? So I will start from V1, sorry, V0. Yes, here. So 8 byte out and 8 byte in, right? Okay, and start from V0. So let's click OK and then go to see here is the data that we already added. And the address will start from 6. Yes, because the existing for S7-300 we already add number 5. Yes. So to test this module, I just add only 8 byte out and 8 byte in. So let's save the project. Yes. And for the address of PLC GE, we'll start from %I 225, sorry, and %Q 113, right? Okay. And then go to download. And in this step, we need to stop the CPU, right? Because we download the hardware configuration. So let's download and write to flash also. because here is S7-200, so we use V memory. Okay, and then I will start the CPU back. So we need to see the data on PLC S7-200, right? So let's go to PLC S7-200 to test. Yeah. So first let's open PLC S7-200. SIMATIC step 7 microwin. Yes. And we will got the data from PLC S7, PLC GE, right? So we will start from V0. Example, I will turn on Q 0.0. Yes. And this one we can command got data from PLC GE bit 0. And then we can download to the PLC S7-200. Okay. And then we can start the CPU. Okay. And then we can online. So if I push the button, yes, from here, or we can force the signal from here. So it will start from Q113, right? So let's go to our table. So %Q 113. And if I force the signal from here, let me put like this, easy to see the status. Because we need to see the status when we force the signal, right? Okay, like this. And one more VMware player, I will put like this. To see the data. Okay, I will adjust a little bit. So wait a moment for adjust. Otherwise we cannot see the status, right? So before for the signal, let me show the status. Yeah, I will explain a little bit about the status. So let's see, the address is select to 6, and if the data is okay, it will show the LED like this. Yeah. And for PLC S7-300 and PLC GE, yeah, Profibus master and Profibus slave is condition is okay. Okay. So if we force the signal, let me force the signal here. Yes. Let's see, the output of PLC S7-200 is turned on. Yes. Because we already config. Yes. So V0.0 is turned on, and then the output is turned on also. Okay, and then we can add more for test. So we can test to another bit, right? So let me outline first and then insert the column. Example here we can put SM0.0, and here should be the next bit, right? So V0.1, and this one should be Q0.1, right? Okay, if we would like to on, we can on. Yes, V0.2, Q0.2. Yes, next we can copy and paste. We can test only one bit, so the bit next is the same. Yeah, 3 bit is enough, so we can download. Yes, we can turn on, and we can online. Okay, so if I force the bit 2, yeah, the bit number 2, let's see, number 2 is turned on, number 3 is turned on, and number 4 is turned on. Okay, and on the PLC is turned on also. So if we would like to feedback the signal, yeah, normally we should have the feedback the signal from PLC Siemens also, right? So the feedback should be like this. Let me test. So for this one, it will start from %I 255, sorry, 225, right? So %I 225, yes, and we can test. If we insert the row, I will insert the row for V 1.0, right? Let's test. Then run the CPU, and then we can online. Let me outline a little bit. Then we can continue, yeah, to see the signal. So let calculation the 8 byte, yes, 1 byte is 8 bits, right? So 8 byte 1 byte, right? Equal 8 bit. So we set 8 byte, right? So 8 byte equal, yes, 64 bits, right? So this one should be V. We can test V64 or V65.0, yes, and then we can test again because we need the feedback from here, right? Okay, let's see. V65.0 is not feedback, right? So we can calculation, yeah. So first 0.0, right? It start from 0, 0, 1, 2, 3, 4, 5, 6, 7, and 8, right? Because 8 byte in and 8 byte out. So this one should be 0.0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, right? Yeah, it is 8 bits, so 1 byte. So another byte is start from 1.0, right? 1.0, 1.1. I will adjust to be 2 decimal place. Yes, like this. Sorry, adjust to 1. Okay, like this. So until 1.2, until 1.7, right? And this one should be 8.0, 8.1 until 7.0, 7.1, 7.2 until 7.7, right? And the format should be the same. Yes, like this. It is the V, yeah, V memory, right? V memory. And it is the input, yes, the input. So the output will start from V, yeah, V memory also, but it will start from 8.0, right? 8.0 until 8.1, 8.2, 8.3, 8.4, 8.5, 8.6, 8.7, right? So if we would like to show the feedback, it will start from 8.0. Yeah, so I will change this one to 8.0. V8.0, right? Okay, so I will download again. After that, we can start and then online. Yeah, let's see. The feedback is show 1. It means that turn on. So if we would like to force this off, let's see, the feedback is off also. Yeah. So we can use 8 bytes in and 8 bytes out, right? So this one should be a 9, 10, right? 11, 12, 13, 14, and 15, right? So it should be a 9.0 until 9.7. This one 10.0 until 10.7. This one also 11.0 until 11.7, and the same as 15.0 until 15.7, right? So many bits that we can use. So this one should be the same as the format, number and 1 digit, okay, like this. So if we would like to show the feedback, yes, number 2, so we can add row, yeah, insert the new row. So 8.1, right? Insert more row. (8.2) and one more for 8.3, right? Okay, and then we can download. So we can link to another slave that we want. Yes. Okay. So if I force this one on again, yeah, it will turn on, off, yeah, it will turn off. Let's see, here is turn off, and for bit number 2 we can force off. Let's see, turn off, right? Turn off also. And this one is turned off also. Okay, so the communication between PLC S7-300 and PLC GE is okay. Yes, so we can map to control, yes, with PLC S7-300 also by using this PROFIBUS. Okay, so if we would like to control from the HMI, yeah, we can do also. Let's go to Workbench. Example, we can go to the existing project. Yes, I will start the project first, and we will create the logic control from the PLC GE, right? to start the output on PLC S7-300. Okay. Then we will go to create the logic. So let's offline first. Okay, I will go to the full screen first for easy to create. After that, we can go to compact screen. Let's go to main program. Yes, we can choose command. So send data to PLC S7-300, right? And then we can also create the start. So NC start S7-300. Stop S7-300. And here command send to S7-300 bit 1, right? Okay, bit 1. And then for the feedback, right, we can use this one, the feedback. Feedback is start from I %I 225, right? Okay, then we can write example feedback S7-300 bit 1, right? Okay, this one we can choose %M. %M also, and this one should be %Q, right? So %Q 113. Yeah, %Q 113. So we can insert %Q 113. Yes, related with this one, right? 113. And for the feedback is %I 255, right? So this one should be %I 225, right? Then we can download. Yes, and we can create the text here. Example sorry, we should create the boolean, right? Example start S7-300 bit 1. So for the bit 1 is %M8, right? okay, %mh. And for stop, %m7, right? So this one should be stop. And %m7. And for the status send from the PLC S7-300 %i 225, right? So %i 255 should be feedback S7-300 bit 1. So %i 225, right? Okay. And then we can create a screen. Yeah, we can edit and then save as one more model. Example screen 2. And then we can edit. Yes. So this one there is no temperature, right? So I will delete motor 2. And for the status, I will use the bit that we already created, right? So feedback from S7-300 bit 1. Yes. If it's true, it will green. And for this one, we just change only the text. So it is the stop button, right? So stop, and then we can copy and then create here. Just copy and paste. And for this one should be start, right? Okay, start. Where is the start? Yeah, here. And we can copy and paste and save the screen. So we can test the screen. Yes. So to test the screen, I will come back to the compact screen. Yes. For easy to see. Yes. So if I push start, let's see here, is turned on, and feedback is turned on also. Yes. And when I push stop, the PLC S7 is stop also. Yes. Start again, it will run again. And I will show the status when we push start and stop from PLC GE. So let's see the status. When I push start, yes, the output is turned on. When I push stop, turn off, turn on, yes. So we can control from the PLC GE to PLC S7-300. Okay. So thank you very much for watching my video. And if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to say I'm sorry if I have mistake in this video. Yeah. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. and I will drop the project file under my video, include the GSD file also. Yeah. So in this time I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today we will go to part 2 about how to link the data from PLC S7-300 to PLC GE by using the Profibus master and Profibus slave linked together. Okay. In the previous video, we already learned about how to create the text and create the link from PROFIBUS Machine Edition and Simplicity linked to SIMATIC Manager and WinCC Flexible. And we also tested with the status. If we send data from PLC GE to PLC S7-300, we can control and it will feed back the signal to PLC GE. Okay. So it just use about the byte memory. So today I will show how to link. We are use the word memory, yes, with the analog, and then we can convert from word to byte also bit, and then we will test together. Okay. So here is the diagram overview of this testing. So I have one switch, Ethernet switch, that link or connect from my PC to the CPE port number 1, and one more port of switch I will link to PLC S7-300 for download the program. Okay. And I have Profibus cable, yeah, that link from Profibus master from PLC GE connect by Profinet scanner and connect to Profibus slave port of PLC S7-300 CPU 314C 2PN/DP. Okay. So let's go to create more or add more memory for word. Okay. And I will explain step by step about how to convert from word memory to byte and then test together. Okay. So let's go. So first let's open PROFIBUS Machine Edition to check our existing project that we already learned in the previous video. Make sure we can connect to the CPU and we can online before we start to add one more memory word. Okay. So in the previous project is PLC S7, right? So let's open. Okay, and then let's test online. Because right now I already turned on power to PLC. Okay. So right now we can online. Okay. And let's see the data. Existing data is still have, right? So we will assign the memory. Yes. So to assign the memory, let's go to our Profinet port. I will assign the memory to this slave more. Yes. Last time we have only 2, right? With byte memory. Yes. Master I slave Q. It means that PLC GE is input and PLC S7-300 is output. And for 8 by more master Q slave I, it means that PLC GE is output and PLC S7-300 is input. Okay, so to add one more memory or another memory, let's go here, configure, and then go to the module, yes, and then click add to add one more memory or another memory. So example, I will add 1 word, yes, or 2 word, yes. Let me add 2 word Q slave Q, sorry, master I slave Q for 2 word. Okay, and I will add 2 word more for master Q slave I, yes. Okay, master Q slave I 2 word more, and then click OK, right? The address will generate automatically. Example for master I, it will start from AI20, yes, and for master Q it will start from %AQ5, yes. Okay, so save the project, and then we need to download to the CPU, right? So before download to the CPU, let's go to SIMATIC Manager, yes, open SIMATIC Manager, because we need to add the more memory to the slave also, right? Slave CPU, yeah. So let's go to hardware configuration, and then go to the DP setting, and go to configuration, yes. We need to add more memory, right? So example, we can create new, and let's see here, master I slave Q, right? So slave should be output. Okay, so we will add output, and the length is 2 word, right? So select 2 word and click OK. So the address will generate automatically, yes. Okay, start from O, yeah, or Q8, right? Okay, and we need to add one more, right, for master Q slave I. So it means that input for slave CPU. So new, and then input, yes, and the length is 2 word, and select all, yes, and then click OK. The memory address will generate automatically also. Okay, okay, and then save the project, and we can ping to the CPU, otherwise we cannot download, right? So test 192.168.0.1, okay, it is the address of CPU, so we can download the hardware configuration. So wait a moment for downloading. Wait a moment. It will detect automatically for the CPU because we had ping. Yes. So let's view to view the CPU. Okay, it found one CPU, 192.168.0.1. So click OK to download, and then restart the CPU after download. And I will show the status. Right now the communication is not okay, right? Because we just add memory. So we need to download to the PLC GE also. Okay, let me show the status. Okay, let's see the status is not okay. Let's see here. It falls because the memory between slave and master is not the same, not match. So we need download to the PLC GE, yeah, to this CPU. Yes. Okay. So let's download. So download, connect to CPU, and then I will stop the CPU because we download the hardware configuration, right? And then download. I will show the status after download. Okay, downloading now. Write to flash. Okay, and then I will start the CPU. After start the CPU, let's see here. The status is okay, yes, no alarm. It means that the communication between master and slave is okay. Okay. So we can write the logic to test communication. Yeah. Send the data and receive the data. Okay. So to create the data, yes, we need to convert from the word to byte, right? Okay. So I will convert the PLC S7-300 first. Okay. Example, we would like to send, right? Or receive the data from the PLC GE, right? So first let's check here. Yes. If we would like to get data from PLC GE, we must use the IH, right? Okay. So example, got data from PLC GE. So we can use the function move. Okay. And then move input, right? So right now input is start from H, right? Here, IH. So I can write IH. Sorry, PIWH. And then here is the memory that we will assign. Example, I will assign with IW IW 1000. Yes. Okay, IW 1000. So if like this, we can convert to byte to bit, right? Okay. Example, the bit number 1. Let me insert one more network. Example, bit number 1. Bit 1. We can write I1000.0, and then example to control the output, right? Example to on the output. Last time we have used the Q136.0, right? So right now I will use Q136.1. okay. And then if we would like to feedback to the PLC GE, we can use we can copy and paste. Example Q0.1. yes, it is the feedback signal to the PLC GE. yes. And for bit number 2, we can also create it. Example bit number 2. Okay, bit 2. We can start from I1000.1, right? And then control the output Q136.2, right? And then the feedback is Q0.2, right? Okay, we can test only 2 bits. Okay, can download and then online. Yes, right now the input is off, right? Okay, because the PIWH is 0. So we need to go to the Proficiency Machine Edition to convert also, right? Before test. So let's go. Okay, main program. I will offline first. And then go to the main. And here we need to convert from binary to decimal, right? Okay. Let me comment a little bit. Example, send data to PLC S7-300 CPU 314C 2PN/DP. Okay. And we need to convert from binary to decimal, right? Okay. So binary. Binary to decimal, right? Here we can use the function block, yes, for convert. I will create the function block. Send to S7. I will import to the main. Yes. And then double click here. We will use the function binary to decimal. Yes. Okay, I will adjust a little bit for dimension. Okay, so we can use the binary to decimal, right? This function. Yes. Enter. Okay. Okay, I will change the height to be 50. Yes. Okay. Then the default is 0 for CMP, and here is the set file. Yeah, set file 535. It is the default. Yes, we can check the manual operation of convert from binary to decimal. Yes, and for the output we will put the %AQ. Yeah, let's check here. It is the output, right? We would like to send. Yeah, here. So it will start from %AQ file. Yeah. So I will put here %AQ file. Okay. And then we can write bit 1 until bit 16, right? Because we have 16 bits for one word. So we can write bit 1 for input, right? Bit 1 until bit 15, right? Bit 2, you can validate. Error 1, right? Because we need to put the input, yeah, until bit 15. So I will drag and drop copy first, and then let's change the name later. Okay, good. So this one should be bit 3, right? Bit 3, bit 4, bit 5, bit 6, bit 7, bit 8, bit 9, bit 10, bit 11, bit 12, bit 13, bit 14, bit 15, and bit 16, because we have 16 bit for one word. Yes. Okay, so let's save the logic, and then we can download. Yes. Okay, download. Okay, good. Right now we already download. Yes. So we need to test, right? So I will zoom a little bit for test. Communication is working or not. Yes. Let's test together. Sorry, my computer is slow a little bit, so I'm also sorry. Okay, so let's check here. Yes. So if I would like to force the signal, example, I force turn on. Yeah, turn on. Pung. here. Let's see this one right, but this one not work. Oh, okay. I confused this one, sorry. We need to use the bit, right? 1001.0, right? Because it will swap, yeah, the word. So let me change this one to 1001.0. Yeah, sorry, forgot to convert sweep, right? It will sweep. So download again. Let's see, the bit is on, yes. Because we need to swap the word, yeah, from right to left, from left to right, right? Because we convert from word to bit, yeah. Let me for the point number 1, sorry, number 2 is turned on, yeah. Let's see, the signal is turned on also. So if we would like to force the signal number 9, right? It should be 1000.0, right? So let me create, because we need to swap the word. Okay, let me edit more, insert network, and then example bit 9. Yes, bit number 9, right? So bit number 9, it should be start from I 1000.0, right? Example, start the bit this one, example Q 161.0, right? Because it 8 bit the same, yes. And then for this one we can write okay, Q 1.0, right? Okay, for feedback. So we can save and we can download. Okay. So if I force the signal bit number 9, let's see here. Okay, it will work. So let's edit more. Insert network for bit 10, right? And then we can use the input I 1000.1, right? For bit 10. And then Q 161 dot, sorry, it is 130 137.0, right? This one also Q 137.1, yes. And for feedback we can write Q 1.1, right? Okay, you can download. So if I force signal for bit 10, yes, I force on bit 10, it will work also. Okay, turn on. And let's see the feedback on the PLC GE. Yes, feedback. Let's go to IO table, right? to see the feedback. Yes, let's see here. The input is turned on also, right? Okay. For bit 10, bit 9 and bit 10 is turned on also. So the communication is okay. So here is very important that we can convert from binary to decimal. Yes, here. Okay, and this is the default number. Yeah. So we will must follow like this. It will work. Okay. So if I would like to remove force off, yeah, it will turn off. Remove force off also. Yes, turn off. And then remove force. From bit number 9, yeah, we can also turn off. Force off, yes, turn off. Remove force. One more. Force off and remove force. Okay. So we can use 16 bits of this signal for one word. For another word, we can also convert. Yes. Example, I would like to convert for word number 2 because we add 2 words, right? Here, 2 words. So if I would like to convert word number 2, we can also binary to decimal also, right? Okay. And here we must put %AQ6, right? %AQ6. Yes. And don't forget put here is this the number, default number. Yes. So 6 5 5 35. Okay. And here example we can write word 2 bit 1. Yes. And we can copy until 16, right? So we just change only bit 1 until bit 16. Okay. So I will change this one to bit 2, word 2 bit 2, word 2 bit 3, word 2 bit 4, word 2 bit 5, word 2 bit 6, word 2 bit 7, word 2 bit 8, word 2 bit 9, word 2 bit 10, word 2 bit 11, word 2 bit 12, word 2 bit 13, word 2 bit 14, word 2 bit 15, and word 2 bit 16. Okay. Then we can save the project and then download. Yes. Okay, download. Okay, download successfully, and then we can config on the PLC S7-300 also, right? So let me offline first, and then go to insert the network. Example, got data from PLC GE word 2, right? So we can also use move, and then move PIW, right? So PIW 10, okay, and then IW, example, IW, this one 1000, right? Okay, 1000. Example, IW 1000. Yes. Sorry, 1001 is already used, right? 1002. Okay. And then we can download. The CPU was stopped, right? So we need to download the block also, right? Okay. Right now the CPU is running, so we can test again. Okay. And then we can go to PLC GE, and then we can force signal to see the signal. If I turn on, yes, force on, let's see here is 1. So we can convert to bits also, right? Okay, example, I will convert to bit. So word 1, word 2, bit 1, right? Okay, word 2, bit 1. So I can use NO contact, and then it will start from I100, sorry, 1002 is bit 9, right? So 1003.0, right? Bit number 1. Example, I will turn on the Persian M. Yeah, example, or Persian Q. Yeah, example, Persian Q 137.2. Yes. Okay. And then let's test it on, right? Okay, it turned on right now. So for bit number 2, we can also do the same. Yes, word 2, bit 2, right? Okay, so we can use I1003.1, right? And for the output, we can use Q137.3. Yes, like this. We can download and see the status. So if I force signal for turn on the bit number 2, yes, let's see, bit number 2 is turned on also. Okay. If I remove force, I will force off. Yeah, for bit number 1 it will turn off also. Okay. So for bit number 9, yeah, and number 10, yes, I will show to finish this step. Example word 2, bit 9, right? So what is the address? So 1002.0, right? Because we must flip from left to right, low to high, high to low. So I will turn on the Q137.4, yeah, something, yeah. And then we can save. And one more example, word 2 bit 10, right? Word 2 bit 10. So we can use input I1002.1, right? And then turn on the Q137.5. Okay. Can online, yeah, to see the status. So if I force on bit number 9 here, okay, it's on. Bit number 10 here, it's on also. Okay. So the signal is work properly between PLC GE to PLC S7-300. Okay. So the next step, we will create the screen for control by through this block to this block. Okay. And in the next video, I will show the more function of analog. Yes. Example, we can send signal from PLC S7-300 to show on the PLC GE, and then we will create the screen to show also, right? Okay. Okay, so I will remove the force signal. Yes, here. So force off and remove force. Force off, remove force, and force off and remove force. Okay. So we can send the signal from this one to control the PLC S7-300 by create the HMI, right? So let's go to create the HMI. So let's open the Simplicity Workbench, and then create a new project. Example, link GE to S7, or the project is long, so I will choose GE to S7. Then we can choose the driver. Yes, I will choose the driver. Yes, this driver. And then I will create the new port. Start from port 0. And then I will create a new device. Example, PLC 1 or HMI 1. and then we will put the IP address, right? So 192.168.0.100. Yes, and then we can start the project. It is very important for link from the GE brand to another brand, yes, to control. Example S7-200 or 300. So we can control and got the data back from the S7 to GE also, right? Okay, the device is up. So we can create the points, right? So before create the point, let's go to enable this one. Example, I will create the project. Yeah, see the logic for control from the HMI to PLC S7-300. So let's go to the main program. Okay, I will disconnect and then create the logic. So example, command start and stop from start and stop control from PLC GE to PLC S7-300. Okay. Example, I will create the NC contact for stop. Okay, stop HMI 1 and NO contact for start HMI 1 and send to this one, right? Okay, I will send to this one. So I can copy this bit, yes, to control this bit, and then I will hold the signal. Yes. So when we push start from the HMI, this bit will on and then send data to the PLC S7-300, right? Okay, I will put %M. Okay. And then I will download. Okay. So we can test. So I will create the new points. Okay, so I can create the new points. It is the boolean, right? Example, stop HMI 1. So %M4, right? This one. %M4. And for start, So start HMI 1, right? And then %M5. Yes. Okay, so we can create the screen. And for the feedback from this one, we can also insert the address, right? Example, %M5, %M6, right? So we can also create the %M6. This one should be HMI 1 signal, right? %M6. Okay. Then I will download again. Okay, so we can create the screen for test. Okay, I will choose the motor, the same as the previous video, and create the start and stop button. Okay, one more for start. And then we can arrange, yes. And this one should be blue, right? Okay. And then I will create one more string. Example, motor 1. Or we can change another color that we want. Yes, I will use this color. And for feedback from the PLC S7-300, okay, I will use the feedback, right? Feedback. This one start the motor, right? So for feedback, let's check the hardware. For feedback should be O, right? OQ O 0.0, Q 0.1, right? Q0.1 is already used. So I will feedback Q0.1. Yes. So for Q0.1 we can check the address here. So master I, right here. So 161 percent I 161 already used, right? So for the feedback, we will vary with the whole the signal. So example, percent I 162, right? It is the bit number 2, yeah, feedback. Okay. And then we can test. Okay, I will add one more for feedback. So create one more point. Or we can use this point. Percent M, right? Percent I 162. Yes, feedback from the PLC S7. And then we can create the command start and status, right? So go to color animation. Yes, I will choose none. Go to color animation and then browse the point that we already created. So this is a HMI signal. Yes, so I will choose the green color when the feedback is okay. And for button start and stop, okay, I will adjust the font, decrease a little bit to be 24. Yeah, it's okay. So button stop, we can go to mount up, new procedure, new absolute set point, browse the point. So the stop, right, set to 0, and new procedure, mount down. Absolute set point stop to 1, right? Okay. And for start is the same procedure, so mount up, new procedure, absolute set point, start, right? So set to 0, and we can copy, new event, mount down, new procedure, new, set to 1, right? Okay. And we can save the screen, example screen 1. Okay, and then we can test. So if I push start, let's see, the signal is sent to PLC S7-300, right? But the feedback from PLC S7-300 is not work. So let me download, because right now the CPU is stopped, right? So let me download all program to the CPU again. Okay, so right now the CPU is running. Yes, then we can test. Okay, I will adjust to be easy to see the overall. Yes. So I will parallel with the bit with this bit, right? So let's test first. Okay, when I push start, let's see the feedback is not come, right? Because the person Q, yeah, 0.1 is not turned on. So if we would like to turn on, we can use this Q, yes, this output. I will delete from this one. We can control H and then paste here. Control Z. Let's test again. This one, right? Okay, this one. So we can copy, or we can cut from here and then paste here. Okay, and then download. So when we push start, let's see the signal is feedback from the PLC S7-300, right? Push stop, push start again, yes. So this one is turned on, and then the person I, yes, person I here, that we already config here, is turned on, right? Yes. Person I 162, yeah, because 161 we already use, right? We already use here from the button start and stop. So if I push start and stop the existing project, it will turn on also, right? Let's see here, if I push start, yes, the existing is turned on, right? Existing program here. And if we would like to synchronize with other point of output here, we can do also. Okay, and we show. Example, we can control, yes, from this one. This output, right? If I push stop, it will stop. Push start again, it will start again. Okay. So for digital by memory, we can link, yes. So if we would like to link the analog, we can add more memory for link, right? Let me show. So I will disconnect first. Example, if we would like to connect the sensor to PLC S7-300, yes, we can also show the status on PLC GE also. Okay, so let me add more memory. So to add more memory, let's go to the Profibus level here and then click config. Yes, and then go to the module. And then if we would like to add example I add 8 word more. So master I 8 word, right? Master I 8 word. Yes, here. Yes, it will come here, and then the address will automatically generate. Yeah, it will start from version AI 22. Yes. So let me download. Okay, we will stop the CPU because we download the hardware configuration. Okay, I will show the connect the temperature and show on the status on the HMI. Yes, by connect from the PLC S7. So wait a moment for downloading the project. Okay, and then I will start the CPU, and then let's go to the PLC S7-300, right? I will close this one first, and then go to the hardware, go to the DP, yes, go to the configuration, and then add new for output, right? Because we need to send the signal to PLC S7, PLC GE, right? So I will choose output 8 word. Then click OK. The address will automatically generate for us. And then save the hardware configuration and then download to the PLC S7-300. So wait a moment for downloading. Okay. Yes. Right now we already download, and I will send the signal from the analog from this module. Example, I will send the PT100, yes, and send the signal 4Y, yes. Okay, to the PLC GE. So let's go to block, right? Create the logic. So insert the network. Example, send the analog signal from PLC S7-300 to PLC GE. Okay. And then I will use the address, right? Yes, the address. So the address will start from PIW256 for the PT100 or RTD, right? But right now I will use the PIW264, yeah, and then to send to the PLC GE, yes. We can online and monitor before we create, because right now I already connected the PT100 and RTD to the PLC S7-300 module here. Yes. So we can online to monitor. Example, PIW 256, PIW 258, sorry, PIW 258, PIW 260, PIW 262, PIW 268, sorry, 64, PIW 266, PIW 270, sorry, 268, right? And PIW 270, okay, because we have 8 channels, yeah. Then we can online and we can monitor as decimal, yeah. So right now I already insert the PT100, yeah, it's so around 26 degrees Celsius, yeah. And for the analog, yes, analog signal for 220 milliamp, right? I will insert the standard saw loop. Okay, and then I will adjust. Okay, let's see the signal here, yeah. So right now I will use PIW256 and PIW266, yes, to send data to the PLC GE, right? So first we can write move. Yes. So I will send PIW 256, right? This one. Yes, 256 from the PLC S7 to the PLC GE, right? So we will use the address here. Yeah, we will use the address because we already configure on the PLC. Yes. So I will use QW12. Yes, QW12. Yes, start from 12, right? So we can use QW12. Yes. And for another channel, we can use the PIW 266, right? So this one for PT100. PT100, and for this one we can copy for signal 4 to 20 milliamp. For 20 milliamp. Right? So we can use more move and move PIW 266, right? 266 to AQW we can type QW 14. Yes. And then we can download. And we can online. Yes. And we can monitor as decimal. Yes. So let's check the signal on the PLC GE. Yes. Because right now we already sent the PT100 signal and 4 to 20 milliamp signal to the PLC GE. Yes. So let's check the AI22, right? Okay. So let's go to check the AI22. So go to the table and then write %AI22. Okay. We will got the data the same as the PLC Siemens send. Yes. Let's see here. So if I adjust the standard soft loop for 220 milliamp, yeah, let me show. I will adjust. Okay, so if I adjust the milliamp, yeah, I will adjust. Okay, I will adjust the milliamp. Let's see the raw value is changed also. Yes. 20 milliamp around 27,000. Yes. And I will hit the sensor. Yes. PT100. And then let's see the status is changed also. Yes. Because right now I already connected the PT100 to this channel. Yes, to this channel. So let me hit. Let's see the signal is start increase, right? I will increase it more. Yes. Right now around 68 degrees Celsius, right? So if we would like to use this signal to show on PLC GE, we can also create the block. Yes. So AI 22, right? It is the temperature. So let's go to blocks. So we can write divide real, right? Example percent AI 22 divide by 10.0, right? So we need to convert from integer to double integer. Sorry, double integer to real, right? So integer to real. This one, and then we can use like this. And let's check. Yeah, it is real. So we will got the actual temperature, right? Example actual PT 100, and we can choose the percent R. Yes. And then we can download. Okay. So right now the value, the actual is around 39 degrees Celsius, right? So if we would like to show this signal on the HMI, yes, we can also use this percent %R, yeah, to show. So percent %R1, I will create one more points. So it is the analog, right? So example PT 100. Sensor 1. So it is the real, right? And percent %R1. Okay, we will got like this. Okay, we will got 38 degrees Celsius. So we can use the text. Let's go to screen and then edit. Example temp winding of motor. So we can use the rectangle. Yes. This one should be white color, right? Okay. And then I will choose the text string. Green color, right? So we can use the points that we just created. Yeah, this one, and it is the real, right? And if we would like to put the precision, yeah, decimal. Example, I put 1 decimal. So we can arrange to be center, yes. And if we would like to show the status, yeah. So right now around 31 degrees Celsius. So I will put the unit also. And the color should be, I will change to yellow color and adjust this font to be smaller than this, 18. And we can group, yes. So example, the 10 winding motor is show signal also from the PLC S7, yes. So if I push start, yes, the motor is running and the temperature should be increased, right? I will hit. Yes, when I hit the PT100, the motor will increase the temperature, right? Okay. I will hit more. Okay. 75 degrees Celsius, yes, for temperature of motor, yes. So this is just example about how to create the Profibus memory, yeah, that link from Profibus master of PLC GE to a Profibus slave of PLC S7-300 by using the Profibus cable, yes. So I hope this video is so long, but I would like to explain step by step about how to configure and how to test, how to create the text or create the feedback memory from PLC S7-300 to PLC GE and control from PLC GE to PLC S7-300. Okay. So if I have a mistake in this video, I would like to say sorry. Yeah. I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to link data from PLC S7-300 to PLC S7-200 and link data from PLC S7-200 to PLC S7-300 back. Okay. So I will use the Profibus cable and Profibus connector. Connect from PLC S7-300 to the Profibus slave of PLC S7-200 model EM277. Okay. And here is the address that we can select. Example, we would like to use the address number 1, number 2, or number 3. We can use the below. Yes. And here is the CPU of PLC S7-200, CPU 222CN. And here is the PLC S7-300, CPU 314C 2PN/DP. And I will add one more for I/O module, 3117KF02. Okay, it is the analog module. Yes. And in this section, I will use two software. The first one is SIMATIC Manager, and the second one for Step 7 MicroWin version 4, speed page 9. Okay. And I will use the PPI cable connect from Step 7 MicroWin to PLC S7-200, and I will use LAN cable connect from my PC to the PLC S7-300. Okay, so I will explain step by step about how to configuration between the SIMATIC Manager and create the logic on the Step 7 MicroWin. Okay, so let's go to our software. So the first one I will configure on the SIMATIC Manager. Yes, so I will create a new folder. Link data. Yes. And let click on SIMATIC Manager to create a new project and hardware configuration. Yeah. So create a new project. So S7-300, S7-200. Okay. It is the project name. And then let's go to browse the folder that we already created. Here, link data. And the first one, let's go to insert the new object of SIMATIC 300 station. And let's go to hardware configuration. So in hardware configuration, first let's go to SIMATIC 300 and create the rack. Yeah, insert the rail to the project. Okay, so let me zoom in a little bit. Okay, and then let's create the CPU. So the CPU is 314C 2PN/DP. So let's drag and drop the CPU to the rack. And here is the default IP address of the CPU, 192.168.0.1. It is the PLC S7-300 IP address. Okay. So right now I already connected LAN cable from my PC to the PLC. So let's ping 192.168.0.1. Yes, we can ping. If we cannot connect, let's go to see the IP address of our computer. Yeah, should be put the manual IP address, the same rank of the PLC S7-300. Okay, so my PC is 192.168.0.2. 253. Yeah, it is very important. So if we cannot connect with the PLC S7-300 by ping command here like this, we cannot download the project to the PLC, right? So it is very important. Okay, so right now we can communication between our PC to the PLC. Okay, so we will go to config the PROFIBUS-DP here. So let's double click mp/dp. Yes. So here is the type of MPI. So if we would like to use the Profibus, we can select here, select to Profibus, and then here is the address of Profibus. Yeah. If we select 2, it means that the IP address, the address of Profibus is 2. Yes, of PLC S7-300. So let me select 2. And for the subnet, yeah, we not yet config, right? So let's click new, and then here is the parameter. Yeah, so transmission rate, let's select to 1.5 kilobyte per sec, and profile is DP. Okay, so let's click OK. We will got one. The address of Profibus is number 2, and the transmission rate is 1.5 megabyte per sec. Okay, and then click OK, and then click OK. Yes. So this is a master, right? Profibus master. Yes, it is the Profibus master, right? Here. So we need to select the Profibus master because it is the master now, right? And for the PLC S7-200, it is slave. Yeah, Profibus slave. So this is a master and this is a slave, right? Okay, so we must select to the master. And for configuration here, we no need to configure. So we need to add the Profibus slave, right? Because Profibus master we already configure. So to add the Profibus slave, yeah, let me adjust like this, and here we can adjust like this. Yeah, because we need to adjust for insert the Profibus slave, right? To add the Profibus slave, first we need to have the GSD file here, EM277. Yes, it is very important for GSD file, otherwise we cannot add the slave module. Yes. So to insert the Profibus slave, yes, let's go to Profibus-DP and then go to the option and then insert the GSD file. Yes, and browse the file that we put. So right now I already put the file on desktop, right? And this is the folder EM277 that I already saw. Yeah, so click OK, and then select here and then select install. Yes, and then click yes, yes again. Yeah, it will show install was complete successfully. Okay, and then close it and wait a moment for installation. Yes. Okay, so we will go to find the EM277, right? Actually we can browse like this, EM277, and then click here. So it will find automatically for us here. Yes. And if we would like to browse, we can also go to PROFIBUS-DP and then go to additional file devices, and then let's go to PLC. So right now we have only one for EM277 PROFIBUS-DP. Okay, and then go to add the memory that we want. Example, I will add 2 bytes, yes, 2 byte out and 2 byte in, yes, or we can add 8 byte out, 8 byte in, yes, that we want. So for the testing right now, I will add 2 byte out and 2 byte in, yes. So let's drag and drop, sorry. The first one, let's drag and drop this one to the network first. So drag and drop and then put here. And it will add the address, yes. So if we would like to add the address here, yes, here. Example, right now I switch to address number 3, yes. So we will put this one for address number 3 here, yes. Actually many address that we can use from 1 to many, right? Many address that we can select from 1 to 1 to 5, right? The last address. Okay, 1 to 5. So right now I will choose 3, yeah. Address number 3 for slave. And then go to property and let's go here, yes. It is correct. Okay. Then click OK. We will got the slave, PROFIBUS slave 1 module, EM277. Okay. And then we need to add the address, add the memory. Example, we add 2 bytes out and 2 bytes in. 2 byte output and 2 byte input, right? It is the meaning. So drag and drop and then drop here. Yes, drop here. We will got 2 byte out and 2 byte in, yeah, and address will start from I 0 0 to I1, right? And the output also I0 to I1 because it is 2 byte, right? So 16 bit, 32 bits, right? Okay, input 32 bits and output, sorry, 16 bit and output 16 bit also. Okay, so totally is 32 bits. So that's all for add the address. And then if we would like to go to check here, we can go to check, yes. Station 0, start from 0, earn 1, start from 0 and earn 1 also for output, yes. And here is the offset memory that we will configure also. Example, we will start from V memory of PLC S7-300, start from 0. We can set like this. I will show after download the hardware configuration, okay, about how to link or how to create the logic to a communication between this PLC, okay. So right now we will start from V0, yes. So click OK and then save the project, and we need to download this configuration to the PLC, right? But before download, let me add one more for analog module here, yes, because the existing project I already insert the hardware. So right now I just insert the software and then download, yes. So let's go to advanced SIMATIC S7-300 SM, yes. And then go to AI, right? Because right now I choose the AI module. So 331 7KF02, it is the module, yeah, made with my hardware. So I drag and drop to the rack, and then I need to set the config the input type, right? Right now the input type I already selected on hardware, yeah, that I already explained in the previous video about how to select the hardware and software to be the same. Otherwise we cannot download or it will show the system fault, right? Okay. So for channel number 1 I will use PT100, channel number 2 0 to 10 volt, and channel number 4 I will use 4Y, and channel number 6 I will use 2Y, okay, 4 to 20 milliamp. And then click OK, and then let's save the project again, and then we will download, yeah. To download the project to the PLC, let's click download button, and then click OK, and wait a moment for automatically detect the CPU IP address, yes. So wait a moment, it will automatically detect for us. Because we we can ping, yes. Right now it detects one CPU is 314C2PN/DP, yes. So let's click view. If we cannot detect, yeah, automatically detect, let's go here, go to set the PG interface and choose the network. It will show the active network automatically, and we can select OK, select OK, it will detect for us, okay. So right now it detects 192.168.0.1, yeah, and here is the MAC address, module type, station name, and module name, okay. So let's click OK to download, and before download we will stop the CPU, right? So let me click OK to stop the CPU, and then restart the CPU again, yes. So right now we already download the hardware configuration to the CPU, right? So we need to create the block to send the data to PLC S7-300, right? So let's go to a block, yes, OB1, and I will choose ladder language. And then we will send the data from PLC S7-300 to PLC S7-200, right? So we can command S7-300 to PLC S7-200. Okay, send data to S7-200, yes. So to send data to PLC S7-200, so we need to know the address, yes, the memory that we send, right? So here is the address that we will send. So it will start from Q, yeah, the output, right, that's sent to PLC S7-200. So it will start from Q0, yeah. So we can choose the function move, yes. I will move IB, example IB 100. Yes, IB 100, right? To the output, right? So output, it will start from Q, right? So QB 0, yeah, QB 0. So if we send like this, it means that we can start from output number 0. Yeah, it is the byte. So we need to move one more byte, right? One byte. Or we can write byte number 1 and one more. Can copy and then paste and change this one to byte number 2, right? Because we send 2 bytes. So we can use move also. Example IB 101, yes, to QB1, yes, okay. And then we can save the project and then download the project to the PLC and we can online, yes. So we need to write the logic on PLC S7-300, right? To got data from this one. Example, we will send the data. Example, send IB 100. I will view as binary, so we can link the signal to example 2 sharp 00001. Yes, I will send 1, yeah, here to the PLC S7-300. So let's go to see the status on PLC S7-300, right? So first let's open SIMATIC, step 7 microwin, yeah. And here we will write the logic, yes. Example SM, so 0.0, and it will start from V 0.0, right? Because the input, yes, will start from 0 also here, hardware configuration here, yes. So V 0.0, yes. Example, I will start Q 0.0, yes. So let download to the PLC and then let's see the status. Okay, so right now the V 0.0 is turned on and Q 0.0 is turned on also. Let me show the status on the PLC, yes. Yes, let's see here, the Q 0.0 is turned on, yes. So if I send 0 from PLC S7-300, so I will send 0, right? Let's see the output is turned off, okay? It means that the communication between PLC master, S7-300, it is the master to the slave, and the data is sent. Let's see the status like this. It will show the LED like this. So example, we take out the cable like this. Let me test. It will error, yes, it will alarm. If we disconnect the cable, yes. Yes, it will show like this, yes. And the master is full also, yes. So if this cable is disconnected, it will error. The system will be error, yes. So it's very important for this cable. So we need to connect with the good condition. Okay. If we connect with good condition, we need to lock, right? Okay, we need to lock the screw like this. And then I will restart the CPU master, because we need to restart. The CPU will run again. Okay. And then we can fork the signal again. Example, I will send 1. Send 1 again, right? Let's see, the output is on again. Yes. So the communication is okay. And then the next step, we need to send the byte number 2, right? Then we force to 0 first. Yes. So example, we need to turn on the output number 2 of PLC S7-300. We can write, yes, like this. Can copy. So we will change this one to V 0.1, right? And Q 0.1. If we would like to turn on one more, yes, can use like this. V 0.2, Q 0.2, yes, and we can download to the PLC again. Yes, and we can monitor again. So if I send the data, yes, from this one, example, I will send with 3 bits, right? So 1, 1, and 1, right? 3 bit. So it will turn on 3 output also, right? Okay, 3 bits. So let's check here. Yes, the output is turned on 3 also, okay, because we 0.1, 0.0, and 0.2 is turned on. Okay, let me force out one by one. Actually, we can view like this for easy to see the status. For S7-300, we can also view like this. Let me test, because right now I use the VMware player with 2 VMware player. Okay, then I will online again. Okay, then we can online, yeah, to see the status. Yes. So if I remove for this 1 to 0, let's see the bit number 3 is turned off. This one I will set to 0. Let's see, the bit number 1 is fall also, yes, 0. This one also. Okay. So this is just the example about send data from PLC S7-300 to 200, right? So if we would like to send the data from S7-200, we can do also, yeah. So let me offline. So example, this one got data from PLC S7-300, right? And this network should be send data to PLC S7-300, right? So it will start from V, right? V 2.0, right? Because the hardware configuration is start from 0 also, yes, for input and output. So we can write, yeah, example M 0.0, and the output should be V, right? V 2.0, yeah, the bit number 1 of the byte number 2, right? Okay, so we can test. I will download to the PLC again. Can online, yes. So let's go to SIMATIC Manager to config, yes, also. So we must write the program here, right? So let me offline and then insert one more network. Yes. Example, got data from PLC S7-200. Yes. So we will use the move function also, right? So I will move IB0, yes, because it will start from 0, right, here. Yes, here it will start from I0. So IB0, example, I will move to IB or MB 100. Yes, it is the byte number 1, right? Byte number 1, we can write byte number 1. Yes, byte number 1. And for byte number 2, we can also create one more network. just copy and paste for byte number 2. Yes, and then use the move function also, right? So I will move IB1, right, to MB101. Okay, and for byte number 1, yes, for byte number 1 we can insert one more network to got data, right? Example, byte number 1, bit number 1. Yes, byte number 1, bit number 1, right? So we can use the NO context. So M100.0, yes, because we start from MB100, right? So M100.0 to control the output, right? Example, I will start the output number 1 of this one. So input and output address is Q136.0, right? So I will start Q136.0. Okay, sorry, .0. And then we can save the project and then download. Okay, so if I for the signal from here, yes, let's see the output is turned on, and let me show the status of PLC S7-300 is turned on also. Yes, let me show. Let's see the output is turned on. Yes, right now. So if I force off, yes, it will off. Force on again, it will turn on again, right? Okay, so communication is okay. And we can also test for byte number 2. Yeah, byte number 2 I will force off first. For byte number 2 we will send, right, byte number 1, bit number 1. Okay, so this one should be we can copy byte number 2, bit number 1, right? So we can use M 0. We can try M 1.0, yes, and then V 3.0, right? Then we can download. Okay, can online, and then we need to write the logic here also, right? Yes, here the byte number 2. So we can offline and then insert the network, and we can copy from here. So the byte number 1 should be changed to byte number 2 and bit number 1, right? So it will start from M 101.0, right, here, and then start the queue. Example, the queue number 2 is queue 136.1, yes, queue number 2. So we can save the project and then download the logic to the PLC. Yes. So if I turn on this one, it will turn on, right? And let me show the status on the PLC. Yes. Let's see, the output number 2 is turned on. Yes. So if I force on one more, let's see, the output is turned on one more, right? If I force off number 2, it will off number 2. Force off number 1, it will turn off number 1. Okay. So right now I will create one more for push button, right? Start from PLC S7-300 to control the output on PLC S7-200. Okay. So let's edit. So here should be send the data, right? Here example I will create here. So I will create one more network. Example start, stop motor from PLC S7-300 to PLC S7-200. Okay. Okay. And then we can write the I/O from this one, right? I will use this one because I will use the push button. Yeah. So I will use I 136 for .0 for start. Yes. So I will use stop. Yes. Sorry, I 136.0 .1 is stop, right? Edit symbol for stop. Stop command. And for start, so I 136.0 for start command. Edit the symbol. Yes, start command. And then we will, yes, move the data, yes, to the PLC S7-200, right? Okay, so we can use output, right? Example Q 0.0, yes. It is used instead here, right? So it will start from 0.0 and we can edit the symbol. Example command start motor, and I will hold the signal, right? I will hold the signal, sorry. Okay, hold the signal by this one. Okay. And then download to the PLC. Yes. So let's see here. If I push button, yes. Let me show the button. So if I push button start, yeah, it will start, right? Yeah, start. It will start. But it not hold the signal, right? If we would like to hold the signal, yeah, we can take out the command, the feedback from here to hold this signal, right? So let's test. So if we would like to hold the signal, we can write like this. I will send to, yeah, insert one more row, and then I will use the V 2.1, yeah, for hold the signal. It is the feedback with by number 2, sorry, by number 1 that sent to the PLC S7-300, right? So here I can use the M100.1, right? 100.1, yeah. So we can save and then download. And if we push the button again, we will got the whole signal, right? Because it is the feedback. So let's test again. Online and test again. Okay, so if I push start, let's see the output of PLC S7-300 is whole. Yes, because we send the data from this memory to the PLC S7-300, right? And if I push stop, it will stop. Start again, it will hold the signal again. Yes. Okay. So if we would like to map with the another memory, we can also do it. Yes, very important. So I would like to summarize of this project. So first we need to know about the memory that we want to send or we want to get from this memory. Yes, this Profibus, right? So the second, the cap ball is very important for cap ball Profibus. Yeah. So we need to lock it. Yes. Otherwise, if the cap ball is disconnect, so the data will be disconnect also, right? So for benefit of this cap ball, we can send and receive the data by using only one cap ball, yeah, from here to here and from here to here by using only one cap ball. By configuration, yeah, we can follow my step for configuration. The first one, we create the hardware configuration of PLC S7-300 and then create the Profibus layout, yeah, and I will drop the GSD file under the description of my video. Yes, because a GSD file is very important. So if we don't have it, we cannot add anything, right? So I hope this video is useful for everyone, and if everyone have any question about the hardware configuration, please drop comment under my video. I will reply soon. And I would like to say thank you very much again, and I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to link data from PLC S7-300 to PLC S7-200 Smart by using Profibus communications. Okay, so I will explain a little bit about how to connection the Profibus cable between PLC S7-300 to PLC S7-200 Smart. Okay, so first we need to have the CPU that built in with the Profibus. Okay, example the CPU 314C 2PN/DP. It has two ports of Profinet and one port for Profibus. Okay, so in this case we can select with the slave or master that we want for PLC S7-300, and for PLC S7-200 Smart we have EM DP01. It means that the Profibus slave module that connected with the CPU SR30. Okay, and here is the connector of Profibus and cable that I already connected from PLC S7-200 Smart to PLC S7-300. Okay, and I will use the software SIMATIC Manager and Step 7 MicroWin Smart link to the PLC S7-300 by Profinet ports and PLC S7-200 Smart by LAN ports also. Okay, and I will use the Ethernet switch one set to use the parallel port. Okay, so here is the overview that we can connect and communication between the PLC S7-300 and PLC 200 Smart. Okay, so let's go to software configuration one by one. I will show with the slow step by step for easy to understand. Okay, so let's go. Okay, so before create the project, first we need to have the GSD file, of PLC S7-200 Smart. If we don't have the GSD file, we cannot make anything. Okay, so let's create a new folder for communication. Example, link S7-300 200 Smart. Okay, and then let's go to SIMATIC Manager. And then create a new project. I will put with the PLC image S7, right? Okay, and then let's go to find the folder that we already created. Yes, here. And then click OK. Yes. And then we need to create the new object, yes, that called SIMATIC 300 station. Okay, and then go to hardware configuration, yeah, double click. So first we need to create the rack, right? So let's go to SIMATIC 300 and rack 300 and insert the rail, yes, and then create the CPU that we want, right? So let's go to CPU 300 tab and then go to 314C 2PN/DP, yeah, here, version 3.3, drag and drop to the right. And here is the IP address of Profinet, yes. I will click OK first. And then we need to create the PROFIBUS-DP, right? Communication. Okay, I will decrease this a little bit. So first we need to go to the MPI/DP, yes, and then go to check or enable the interface, right? So right now I will use Profibus, and here is the address, yes, that we can put. Right now I will put 2 for master, yes. Here the new, and here is the selection that we can select. Normally we use 1.5 megabyte per sec for speed, yes, and profile is DP, yes, and then click OK, and then click OK again, yes, and then click OK again. Okay, so after that we will got like this, yes. So we need to create the slave, right, for PLC S7-300 Smart. So to create the Profibus slave, we need to have the GSD file right here. So to install the GSD file, let's go to option and then go to install GSD file and then browse to find the folder that I already put the file GSD file of PLC S7-300 Smart on desktop. Okay, so click browse and then go to find the folder here, yes, or here. So click OK and then click here, or we can select all and then install it, yeah. After install, let's see here, install was complete successfully. Okay, and then click OK and then click close. Okay, and then we can find the module, yeah. After that we can find the module. To find the module, let's go to see the Profibus-DP and then go to the additional file driver, devices, and then go to PLC SIMATIC. Okay, and then we can see the module of Profibus slave or PLC S7-300 Smart. Okay, in the previous video I already add one more for EM277 for Profibus slave or PLC S7-300, and here is the Profibus slave of PLC S7-300 Smart. Okay, so let's drag and drop to the network here, and then it will add the address that we want to select, right? So it will relate it to here, yes. Here we have the selection. Yes. So I will use the address 1. Yes. For Profibus slave. And here is the transmission rate. Yes. Okay. So for the Profibus master, I already select with the address number 2. And for the Profibus slave or PLC S7-300 Smart, I will select address 1. Okay. And then click OK. And here we can add, right? We can add the memory or data that we want. The first we can select 4 bytes in out. Yes. So to select it, let's drag and drop it to the module. Sorry, double click here first. Yes, like this. And then we can drag and drop here. Yes. Okay. To slot number 1. So slot number 1, it will start the address. Example here we can use the address that we want. Example, I will start from 0. And here I also start from 0 also. And the address will automatically generate for us. Yes. Okay. So output, it will start from 0. And input, it will start from 0 also. And okay. And the length of this memory is 2 bytes in and 2 bytes out, right? Okay. So that's all for this memory. So next we will download the configuration to the CPU of master, right? Profibus master. So we can save the project and then download. Yeah. Before download, make sure we can communication between our computer with the PLC, right? So 192.168.0.1. Okay. So we can download. Okay, I will set the temporary set PG PC interface. Okay. And then let's go to this one. Yes. Because right now we use LAN cable, right? Okay. And then let's download again. So wait a moment for detecting between our PC with the PLC. Okay. It will automatically detect. Okay, right now it detects one CPU address 192.168.0.1 and we can view. Okay, and then we can click OK to download. Yes. Okay, after download, we will restart the CPU. Yes. And then we can go to PLC S7-300 Smart software to configuration also, right? So let's go. So let's open SIMATIC Step 7 MicroWin Smart. And then go to see the CPU, right? So first communication. Let's check communication. Okay, the CPU smart is 192.168.0.2. Yes, and then go to create the hardware configuration, because it's very important. If we not create the hardware configuration, it doesn't work. Okay, it not the same as the PLC S7-300. Yes, for S7-300 software, we no need to create or configure the hardware, but if we use the PLC S7-300 Smart, we need to make the hardware configuration, otherwise it cannot work. Okay, let's go to create the hardware configuration. Yeah, if we select like this, yeah, we will see the EM DP01. Yeah, and here we can also select the battery. Yes, like this. Okay, so let's go. If we done, yes, select like this, because it is the module of PLC S7-300 Smart Profibus level, right? Click OK to confirm. Okay, so we can download, yeah, after configuration. Yes, after download, the CPU of both it's running. Yes, and then I will show the status. Yeah. Okay, here is the CPU of PLC S7-300. It means that master, yes, right now it run, and for the CPU of PLC S7-300 Smart is run also. Yes, and here is the data. If it link, it will show like this. Yes. Okay. So the communication between Profibus master and slave is connected properly. Okay. So we can create the logic for test. Okay, so before test the configuration, let me explain a little bit about the memory. Yes. So 4 by in and 4 by out, right? It means that we can convert to bit, right? If we choose 4 by, let me go to the logic, easy to explain. Okay, go to OB1. Okay, let's open. And if we would like to send the data, example, send data from PLC S7-300 to PLC S7-200 Smart. So we can do it by move the data. Yes, I will use move. Okay, I will zoom. So here is the address. It will start from 0, right? Okay, 0 to 3. It means that 4 byte out. So right now we will generate the output to send to the PLC S7-200 Smart, right? So we can move, example, IB10, move to QB, 0, right? Because it starts from 0 here. The address is start from 0. So we will use QB0 for byte number 1. Yes. And for byte number 2, we can also use move. Example, IB11 send to QB1, right? Okay. It is 2 byte. So if we use 4 byte, we can also insert one more network. This one for byte 1 and 2. And this one we can copy and then paste 3 and 4, right? Okay. And then we can use move. So example IB12 move to QB2, right? And one more for byte number 2, sorry, byte number 4. You can also use move IB13 to QB3, right? Because the address is start from 0 to 3 here. So it's enough. And then save the project and then we can download. And then we can online. So if we send the data, we can go to the PLC and then go to the monitor modify. Example IB10 and view as binary. We can monitor and then we can for the signal like 2 chaff 000 underscore 001 example. Let's see. We will send one to the PLC S7-300 Smart, right? So if we would like to check the data on PLC S7-300 Smart, we can go to see the data. So we can write the logic with the V memory, right? Let's see here, it will start from the V memory, right? Here, it will start from V0. Yes, here. So V 0.0, right? Example, I will on one output that called Q 0.0. So if we download the data to the PLC and then we online, we will got 1. Okay, right now we will got 1. And if we force the signal to 0, let's see here. I will force to 0. Let's see, S7-300 Smart is turned off. I will force 1 again. Okay, the PLC S7-300 Smart is 1. Okay, so if we would like to use another bit, okay, we can create more. Example, this one got data from PLC S7-300. This one should be by 1. bit 1, right? And if we would like to use the bit number 2, okay, I will insert one column and then insert like this, SM0.0 all the way on, and we can copy and then paste. So this one should be V0.1, right? And this one should be Q0.1. So bit 1 and bit 2, yes. And then we can download, run the CPU. Okay. So right now, I would like to enable the bit number 2. We can for this one to 1. And then we will got the bit number 2 is turned on. Okay. We do the same step until bit number 8 for byte number 1. Yes. We will got this data. Okay. So let's create to another byte. So if we would like to use the byte number 2, yes, example byte number 2 here. Okay, byte number 2. So all the way on also, and then I will use the V. Okay, V. It will start from V1.0, right? For byte number 2. Example, I will use the output with the Q0.2. And for byte number 2 of bit number 2, I will use example Q0.3. Yes. And this one should be V1.1, right? Okay. Then we can download. Okay. And we can monitor like this. Okay. So this one should be IB. Yes. Let's see here. For byte number 2, it should be IB11, right? So IB11. And I will view as the binary also. And here we can forward the signal by 000_001, right? So if I forward the signal, let's see. Yes. If I forward the signal, let's see the byte number 2 of bit number 1 is turned on. And number 1 for bit number 2 it turned on also. Okay. So the link of data communication between PLC S7-300 to PLC S7-200 Smart is okay. Okay. So if we would like to use another byte, we can use IB12, IB13, right? And view as binary also. Okay. And this one should be, yes. Okay, I will test to make sure everyone can use after watching my video. So I will use always on, and this one should be beacon command. And then we can insert the NO. So this one should be start from V 2.0, right? And output this one should be Q 0.4, right? And one more. If we would like to use the bit number H, yeah, we can also use 2.7, right? Bit number H. This one should be Q 0.5, yes. So we can download and then test the signal, yes. So if I follow the signal from the PLC S7-300 000 underscore 0001, right? Okay, bit number 1 of byte number 3 is turned on. And if we would like to use the bit number H, we can for this one. Yeah, let's see, bit number H is turned on. Yes. So we will create one more for byte number 4. Yes. So this one byte number 4. This one byte number 3, right? Okay, sorry. So we can use the same as procedure, and we can go to V 3.0, right? And for the output, I will use Q 0.6, sorry, Q 0.6, and one more for bit number 2 of byte number 4, I will use Q 0.7. Example, this one 3.1. Yes. Can download again. Start the CPU. And then go to IB 13, right? So this one should be 2000 underscore 000. Yes. If we would like to for the bit number 1, we can force the signal. Yes. Turn on. Bit number 2. Turn on also. Yes. So every byte and every bit is communication, okay, right? Between PLC S7-200 Smart to PLC S7-300. Okay. So if we would like to send the data from the PLC S7-200 Smart to PLC S7-300, we can also do it. Yes. So if we would like to send, we will use the output to send, right? Okay. So let's go to C. Example, send data from PLC S7-200 Smart to PLC S7-300. Okay. So let's see the address here. The input is start from 0 also, right? So I will create the PLC S7-200 Smart first. Example, I will use M. Okay, I will use SM 0.0 for always on. And then I will use M 0.0. And then it should be V 4.0, right? Okay. And for bit number 2, we can also use M 0.1 and send to V 4.1, right? Okay, let's test together. Okay, can online. Okay, And let's go to the logic, right? Okay, I will outline first and insert the network. Example, this one should be got data from PLC S7-300 Smart by number 1, bit 1 and 2, right? So I will use move. Okay, so it should be move this one IB, right? Should be IB 0, and this one should be example. I will use MB 0. Yes, let's test. Okay, so if I force the signal from PLC S7-300 Smart, okay, I will write 1. Let's see this one. Yeah, I will write 1 also. It will got 3, right? Because it is show with the decimal. Sorry, it's a decimal. If I would like to use the binary, okay, we can use like this. Insert network, and then we can write, sorry, IB M 0.0, right? Example, I will turn on the output. So output, it will start from, sorry, I will check. It will start from 136.0, right, for output. So Q136.0. Okay. And for bit number 2, this one bit number 1. Okay. I will zoom a little bit. Okay, like this. And for bit number 2, can use M 0.1, Q 136.1, and then download, and we can online. Yes, let's see, bit number 1 and number 2 is turned on, right? Okay, so if I remove false, okay, it will turn off also. Okay, so for bit number, sorry, by number 2, number 3 and number 4, we can do also. Yes, okay, so we can edit for by number 2. Yes, so we can move. So this one should be okay. I will zoom a little bit small. Yes, so this one should be IB1. Example MB1, or we can move IB2, right? MB2, and the last one move IB3 MB3, right? Okay, so this one should be 3 and 4, right? Then we can save and then download. Okay, so let's see the data. Okay, so for byte number 2, we can also continue with here. Example, I will move, sorry, start M. Example, this one should be 1.0. V should be V5.0, right? Okay. And for bit number 2, can use .1 and this one M1.1. Yes. So let's see the data. Okay. So if I force M, let's see here 1, 3. Yes. So it worked correctly. 1, 3. Yes. So for byte number 3 and number 4, we can continue with M1, sorry, 2.0, and then should be V6.0, right? Okay, I will use only one bit. And for bit number 4, so sorry, byte number 4, I will use 3.0, V7.0, right? So many bit, many points that we can use. Okay, so let's see here. Okay, I will zoom a little bit. Okay, so if I follow the signal, let's see 1, this 1 also, right? Okay, so the communication is okay between master and slave of Profibus. Okay, so next I will create the HMI for start and stop to see the signal, right? Okay, so let's go to the WinCC Flexible, and then create a new project. I will create the project with the HMI. I will use TP 177B SEQUENCE color. Okay, so let's go to create the new connection. Example HMI 1. Yes, and we need to select the Ethernet, right? And here is the IP address of our computer. So 192.168.0.253. Yes, because it my computer connection. Yes, here. And here is the IP address of PLC. So 192.168.0.253. dot 0 dot 1. Yes, and here we can comment connection of PLC S7-300. Okay, and we need to create the text, right? Because we need to show the bit status that send the data from the PLC S7-200 Smart. Okay, so I will start from Q136.0. Okay, so let's go to the text and create the output 1. So it is the boolean, right? So we choose boolean, and it should be Q, right? So 136.0 output number 1. Yes. Okay, and for output number 2, yeah, automatically created. Output number 3, output number 4, output number 5, output number 6, output number 7. So this one we can copy and just change to output number 2, output number 3, output number 4, output number 5, output number 6, output number 7. Okay, so it just example. Output number 8. Okay, so we can create, yes. So this one just 2 bits, so I will create more. Yes, so I will use 2 bits for each byte of this one. Okay, I will insert network, and this one example got data, or we can write only bit number 1. This one by 1, by 1 bit number 1, right? This one by 1, bit number 2. Okay, maybe I change this one to 2. Okay, we can use 2. For this one we can use NO, so it should be this one, right? So this one should be M1.0. So this one should be by 2 bit 1, by 2 bit number 1. Yes, I will use Q136.2. Yes, and one more. by 2, bit number 2. Yes. So I will use M 1.1, right? And then turn on the Q 136.3. Yes. So the next step, we will create this one, right? So we can copy by 2, bit number 1. So this one should be by 3, bit number 1, right? And O. So should be this one, right? M 2.0. Can copy and then paste, change this one to 4. One more. By number 2, by number 3, bit number 2. So we can copy 2.1, Q136.5. Yes. And the next step for by number 4, right? So insert and then copy. By number 4, bit number 1. This one should be M 3.0, right? M 3.0. Because here MB3. So convert from byte to bit. Yes. So this one I will copy, and then this one should be 6, right? Okay. Okay, so the last one, by number 4, bit number 2, right? Then we can use M 3.1, right? So Q 136.7. Okay, it is the last one. So save the project and then online, right? Okay, so I will remove all false from this one first. 0, 0. Okay. Zero, 0. Okay. So the false has been removed right now. And then let's go to C. I will remove false from S7-300 Smart also. Okay, this one. Oh, this one should be false from this one, right? I will turn on. Sorry, turn off. Okay, for this one, command from the PLC S7-300, right? Let me check. This one all is 0, right? Oh, this one. Okay. Okay, good. So let's create the script. So first, I will create the screen, yes, for bit number 1 until bit number 8. This one we can design like this. Show status bit of S7-300 module. Okay. I will change the color to be this color, and the text should be yellow, right? Okay, good. Okay, bit number 1, I will change color to be red. Yeah, it means that it's off. So here we can choose the color animation and then choose the text. Output 1, right? So if we change this one, it should be changed to green, right? If it's on, it change to green, and then we can test by simulation. Yes, sorry, this one should be 0, should be 1, right? Okay, so if I turn on from PLC S7-300 Smart, okay, this one, okay, let's see the bit number 1 is change the color, right? Because here is turned on. Okay, if I turn off here, it will change the color also. Okay, so we can design with another bit. So this one should be bit bit 1. Okay, then we can copy bit 2, bit 3, bit 4. Okay, like this, and we can arrange. We can arrange to be like this. Okay, So this one should be bit 2, bit 3, bit 4, and for bit 5, 6, 7, 8 we can copy, Control Shift drag and drop. So this one should be bit 5, bit 6, bit 7, and bit 8. Okay. So this one should be change only output 2. This one output 3. This one output 4. This one output 5. Output 6. Output 7. Okay, so this one should be number 8, right? Then we can simulation. Okay. So let me for the signal. So we need to revise this one. Yes. Because 1 byte we use only 2 bits, right? Okay, I will revise. This one correct? Why correct? This one should be V 6.1, right? And one more M 4.0 should be V 7.0, right? And one more M 4.1 and V 7.1. Okay, so let's download. Okay, and online. So let's see if I turn on. Yes, let's see the bit number 1 of PLC S7-300 is turned on. Bit number 2, yes. Bit number 3, bit number 4, bit number 5, bit number 6, bit number 7, bit number 8. Okay, so turn on 8 bits. Yes. So if we would like to send the data from PLC S7-300 to S7-200 Smart, yes. Let's create the one more screen, or we can adjust. Okay. So we will send the data, yes, from here to the PLC S7-200, right? I will insert the network, send data. to PLC S7-300 Smart by push button. Okay, so we must choose this one, right? Okay, so we can use like this, M example 20.0, and then we'll turn on this bit, right? And then we will turn on the Q0.0, right? Q0.0. Insert one more. This one output Q0.0, right? And for this one Q0.1, so we can use M20.1, and then I will move, yes, I will use this one Q1.0, yes, and one more. Maybe I will use only 4 bits that send the data from PLC S7-300 to PLC S7-200 Smart. Okay, so this one we can copy, change this one to 2, and this one should be 2.0, right? Because this one, yes, and the last one we can use .2.3, right? This one should be Q3.0, right? Okay, so we can save the project and then download. Okay, and then we will create the push button or switch that can start from the HMI, and then let's see the status on the PLC S7-200 Smart, right? Okay, so first let's go to text PB1 or switch 1. Okay, switch number 1 M20.0, right? Okay, so switch number 2 20.1, switch number 3 20.2, switch number 4 20.3, right? So switch 1 switch 2, switch 3, and switch 4. Okay, and then we can go to insert the switch. Switch 1, right? Okay, and then we can test. Or we can use button. Yes. Switch 1, we can go to event and then click invert bit, right? SW1, and for SW2, SW3, and SW4, we can copy. Okay, and we can align. So this one should be switch 2, right? Switch 3 and switch 4. Okay, and then change event to be SW2, SW3, and SW4. Okay, and then we can simulation. So we need to modify, yes, or we no need to modify. Let's see here. Okay, and I will show the status on the real PLC. Yes, when we select. We will start from bit number 1. Yes. So if we select bit number 1, yeah, let's see output is turned on. Yes. Okay. And for PLC S7-300, the output is on also because we turn on from this one. Yes. if I remove force, let's see, it turn off step by step. Yes. Two bits more. Yes. And the last one. Okay. So communication between the PLC S7-300 or master send to and receive data from PLC S7-200 Smart is working properly. Okay. So thank you very much for watching my video. And if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next video. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to link data between PLC S7-300 to S7-200 and to PLC S7-200 Smart. Okay. In the previous video, we already learned about how to link data between PLC S7-300 to PLC S7-200 Smart. Okay. And in this section, I will use PLC S7-200 and 200 Smart linked together to PLC S7-300. Okay. And I will use three software in one. The first one is SIMATIC Manager. The second one is Step 7 MicroWin. And the third is the Step 7 MicroWin Smart. Okay. Before go to create the new project of this section, I would like to explain about how to connect the Profibus cable connector from the PLC to other PLC. Okay. So here is the SIMATIC Manager. Yes. And here is the SIMATIC PLC S7-300 that we connect the Profibus connector to Profibus port of CPU 314C to PN/DP. Okay. After that, I will connect to the PLC S7-200 EM277. It is the Profibus slave module. Yeah. And for address, I will select to 1. Yeah, for S7-200. And I will use the connector. Yes. Link continue to the PLC S7-200 Smart EMDP01 module. It is the Profibus slave also. Okay. But the module is not the same because it is for use for CPU of S7-200, and for this module used with the PLC S7-200 Smart. Okay. So we need three connectors from connector number 1 to number 2 and number 3. And for address of Profibus or PLC S7-300 Smart, I will use address number 2. Yes. And for configure the software, I will use LAN cable, connect with Profinet port or PLC S7-300, and one more port for PLC S7-200 Smart. And for PLC S7-200, I will use PPI cable. Okay. So let's go to see the configuration, hardware and software together, and then download to the PLC for test the signal or test the data together. So let's go. Okay, so first let's go to create the new project, right? Before create the new project, I will create the new folder. SIMATIC link. Yes. Okay. And then let's go to SIMATIC Manager first to create the master PROFIBUS-DP. Okay. So let's open. After that, let's go to File and then choose New. And SIMATIC, I will put the name of project is SIMATIC S7. And then browse to find the folder that we already created on desktop. Okay, SIMATIC link. And then click OK button. Yes. And we need to create the rack, right? Okay, to create the rack, we need to create the new station of SIMATIC 300, right? So let's go to right click and go to insert new object, and then go to SIMATIC 300 station. Okay, and go to hardware, double click on hardware, and we need to create the rack, right? So let's go to SIMATIC 300, go to the rack, insert the rail to the project. It is the rack, right? So we can use 11 ports, 11 slots of one rack. And then we will add the CPU, right? For CPU, let's go to CPU 300 tab, and then go to CPU 314C 2PN/DP, and I will use version 3.3. Okay, drag and drop to the rack. Here is the IP address of the module, and then click OK. And we need to create the Profibus master, right? Parameter, double click here, and then choose the Profibus for interface. Yes. And then choose the address that we want. Right now I will use address number 2, but I will change to okay, for this one I will choose number 2, and I will adjust the PLC S7-200 and 200 Smart to another address. Okay. And then here is the transmission rate. Yes. Profile, choose DP, and transmission rate choose 15 megabyte per sec. and then click OK, and then click OK one more time. Okay, and here is the address. So we must config with the master of DP. Okay, so that's correct, and then click OK, and we can save the project. Yes, and we need to add the Profibus slave, right, on this network. Yes, so to create the Profibus slave on this network, we need to have the GSD file, right, the same as the previous video that I already show about how to install the GSD file of Profibus slave. Yes, I will show the file. Yes, we need to have the Profibus slave GSD file. Yeah, we have these two files. The first one is EM200 for GSD file. Yes, and the second, we need to have the DP01 GSD file. Yes, so I will show again about how to install the GSD file from this folder. So first, let's go to hardware configuration, and then go to option, and then install the GSD file. Yeah, so let's browse the GSD file that we keep on desktop. So I will install the EM200 first. Let's select here and then click install. Click yes. Yes. Install was complete successful. And then click close. It will automatically import the file data to the hardware tab. And we need to install the GSD file of PLC S7-300 Smart also, right? So let's go to option, then go to install GSD file again. Browse to find the file that we already keep on desktop folder. So we can go to this one, yes, and then click here and then click install. Okay, install again. Install was successful, yes, and then click close. Okay, and if we already install, we can use it by we can go to browse here, go to the additional file devices, go to PLC, and go to SIMATIC. We will got two files there. The first one is EM200. The second one is EMDP01. Okay. So to use this file, we can go drag and drop the file to the network. Yes. Let me drag this one a little bit. Okay. Okay, so we can add the Profibus slave of PLC S7-300 Smart and PLC S7-300 here. Yes. So to add the Profibus slave, let's go to additional file devices, and then go to PLC, go to SIMATIC, and then drag and drop the EM277 or EMDP01 or PLC S7-300 and 200 Smart to the network. So basically I will add the Profibus of PLC S7-300 Smart first. So I will drag and drop this one to the network. And here is the address that we will choose. I will choose the address number 1 for Profibus layout of PLC S7-300 Smart. Yes. So let's select to 1. And for this address, it will relate it to the slide. Yeah. We can select here. I will show on the real PLC. So we can select to position number 1 of Profibus module. Yes. So I will use the address number 1 for PLC S7-300 Smart and go to property and then go to network setting. Normally we use 1.5 megabyte per sec, and for profile we use DP. Okay, so select 1.5 for transmission rate and profile is DP. Okay, and then click OK and then click OK. We will got like this. So we must add the memory, right? So to add the memory, let's go to here and drag and drop the memory to the slot. Yes. So we will get like this, 4 bytes in and 4 bytes out, and the address will start from I256 to I259. Okay, so basically we can rename the address here. Yeah, example, I will start from 0, so I can put 0. Yes, so 0 to 3, it means that 4 bytes input. 0 to 3, it means that 4 bytes output. Okay, and let's check the V memory. We will assign the offset also. So for PLC S7-300 Smart, I will start from V0. Yes. So that's all for configuration PLC S7-300 Smart Profibus. So let's save the project. Yes. And the next step, we need to insert or connect to the Profibus slave of PLC S7-300 also, right? So to add, we use the same procedure, drag and drop this module to the network and then choose the address. For address number 1 and number 2 is already used, right? Address number 2 is for Profibus master, and address number 1 for PLC S7-300 Smart Profibus slave. So we cannot select number 1 and number 2 here. So we can also select number 3. Yeah, we use address number 3 for PLC S7-300 Profibus slave, and go to property and then go to setting, network setting. Yeah, we choose the same for transmission rate and profile. Okay, and then click OK and then click OK. Yes. Let's see, here is 1, it means that address number 1, and here 3, it means that address number 3. So we need to add the memory also, right? To add the memory, let's go to here and then go to add the memory length that we want. Example, we can add 1 byte out, 1 byte in, 2 byte out, 2 byte in. Okay, so basically I will use 2 byte out and 2 byte in, drag and drop to the, okay, click this one first, drag and drop to the slot. Yeah, and it will automatically generate, yes, from address input number 4 to input number 5, because we have only 2 bytes, right? And for output we had only 2 bytes also, so it will start from 4 to 5. Yes, because the address number 0 to address number 3 we already use for PLC S7-300 Smart Profibus, and for this one it will generate and start from address number 4 to number 5. Okay, and then go to see the V memory also. I will assign from V0 also for PLC S7-300. Yes, and then save the project. And we need to send the data or receive the data from PLC S7-300 and 200 Smart, right? So we can go to create the block, yeah, create the logic for send the signal and show the feedback signal. Yes, basically this one we can command example send data from PLC S7-300 to PLC S7-200 Smart. Okay, I will send to the PLC S7-200 Smart first. So we need to move the data, right? To move the data, we can use function move. Yeah, we can write move, and then we'll move the byte memory to the output, right? Because we need to send the data. So for the PLC S7-200 Smart, I will use address start from 0, right? So we can use move IB example 100. Yes, move to QB0, right? QB0. Okay, for byte number 1, byte 1, 2, 3, and 4, right? Because we use 4 bytes for PLC S7-200 Smart. Yes. Okay, so this one we can use byte number 1, and for byte number 2 we can also move example IB 101, and this one should be QB1, right? So QB1, and for number 3 and number 4 is the same, right? So I will add more, or we can insert one more network. Yes, and copy this one, number 3 and number 4, right? This one number 2 and number 1. Yes, so we can move example IB 102, and then QB 2, right? And for byte number 4 we can also use move. This one should be IB 103, and this one should be QB 3, right? Okay, that's it. Save the block, and we need to send the data to PLC S7-200 also, right? So insert the network. Okay, we can copy like this and then paste and just change. Yeah, 200, and then we can use move. So PLC S7-200 we use only 2 bytes, right? Here. Okay, 2 bytes, and the address will start from 4 to 5, right? So we can use example, I will use IB 200. Yes, and then should be QB4, right? Because 1, 2, 3 we already use, right, for PLC S7-300 Smart. So this one should be start from QB4, and one more move example IB 201, yes, and then move to QB5, right? Okay, QB5. Then we can save the project, yes. And one more thing, we can get the data from the PLC S7-300 Smart or PLC S7-300 also, right? But I will show in the next step. So right now we need to download this project to the PLC, right? So before go to download, let's go to create the project of PLC S7-300 Smart first. Okay. So let's open SIMATIC Step 7 MicroWin Smart. And we need to configure the same as the hardware, right? So for PLC S7-300, we don't need to insert the hardware yet. We just connect and we can use it followed by address that we configure. But for PLC S7-300 Smart, we need to configure the hardware for Profibus level. Otherwise, it not work. Okay. So to add the hardware configuration, let's follow this one. Yes. The first one is CPU and the second one is Profibus module. Yes. So let's go. So first, let's go to CPU SR30. Yes. And then go to the startup, and then I will use run. If power on, power off, and power on, I will run the CPU. And for the SB, I can use battery. And for EM0, I will use Profibus. Yeah. EM DP01. Yeah. It is the Profibus slave. And let's read here. The DP01 module is configured by the DP master. There is no configuration required for this module in step 7 MicroWin Smart. Okay, so we just insert or configure the hardware, yeah, and at the method we no need to configure. Okay, so we configure only like this, you can use it. And then we need to create the logic to got the data from the PLC S7-300, right? Okay. So we can command. So get data from PLC S7-300 byte 1. It means that byte number 1. So byte number 1, it will start from V0, right? Because here we use V0. Yes, V memory is V0. So we will start from V0. So I will add always on. So SM0.0 always on. And then I will use the nominal open. So it will start from V0.0. And I will turn on the output Q0.0. Yes. And for another bit, we can copy, yes, H bit, right? So 1, 2, 3, 4, 5, 6, 7, and 8. And we can use arrow key, control, press control and then arrow key to connect the wire. And this one I will change to V0.1, V0.2, V0.3, V0.4, V0.5, V0.6 and V0.7, right? And output I will turn on this one should be here, Q 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. So this one should be Q 0.2, Q 0.3, Q 0.4, Q 0.5, Q 0.6 and Q 0.7. Yeah, for byte number 1. Yes, so 1 byte it is 8 bits, so we can use 8 bits that get the data from PLC S7-300. Okay, so we can save the project. Link from PLC S7, or we can write link with PLC S7-300. Yes, and for byte number 2 we can also create. Yes, so I can copy. After that we can download to the PLC and then test one by one. Okay, byte number 2, and I will add the always on. Yes, so SM 0.0, and for byte number 2 it will start from V1.0, right? So V1.0, and I will turn on the M, example 0.0. Yes, then we can copy eight bits, right? So 2, 3, 4, 5, 6, 7, 8. Okay, and this one should be M0.0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6 and 0.7. Okay, M0.1, M0.2, M0.3, M0.4 and M0.5, M0.6, M0.7. Okay, so for reference testing we can test only 2 bytes. Yes, we can apply with another byte that we already configure. Yes, so let's save the project, and next step, let's download this program to the PLC and then test together. Okay. Okay, so we can download the project to the PLC S7-300 first. Yes. So before download, let's check by command ping 192.168.0.1. Yeah. So like this, it means that we can connect or communication between our PC to the PLC. Okay. Because right now I already connected the LAN cable from PLC S7-300 to my PC. Yes. So let's go to download. So wait a moment for detach the CPU. It will automatically detect if the computer is ping from the PLC. Okay. Okay, so right now it detects one CPU address 192.168.0.1. So click U. And then click OK. Yes. Then click OK. And then click Yes to start the CPU back. And then we can go to download the PLC S7-300 Smart, right? But before download the PLC S7-300 Smart, I would like to show the address that we can select. Yes. Actually, we can select from 0, 1, 2, 3, 4, 5 until 10. Yes. Okay, let's see here. Right now, I already select to the address number 1 here. Yes. For CPU SR30 and EM DP01 or PLC S7 Smart. Yes. So we can download by press here and then find the CPU, and we can download. Yeah. Stop the CPU and then download. Yes. And we can online after download. Then we need to send data from PLC S7-300. Yeah. Here. Let's see if it show like this. It means that the communication is okay between PLC S7-300 and PLC S7-200 Smart. Okay. So if we would like to send the data, we can send. Yeah. Okay, let's send the data to see the status. So we can online here. And I will send the byte number 1 to the PLC S7-200 Smart, right? So we can go to PLC and then go to monitor modify. Yes. And then I will start from IB100, right? So IB100. And I will view as binary. Yes. Then I can online here. And here we can use like this. If everyone would like to send the bit number 1, we can write like this and then turn on or modify. Yes. Let's see. Here is turn on the address number 1. Yes. Bit number 1. Yes. So if we would like to turn on the bit number 2, we can turn on here. So bit number 2 is turned on. So if we would like to turn on bit number 3, we can turn on bit number 3, bit number 4, yes, bit number 5, yes, turn on. It means that the communication is okay between this PLC. Yes. And the last one. Okay, turn on. So if we would like to send data for byte number 2, yeah, we can also send data. So IB (101), right? So the default is like this. Okay, so if we would like to forward the signal for bit number 1 or byte number 2, we can start from 1. Yes, it's the same, yeah, because I'm not yet rename, yes, the address. So let me rename the address. This one should be 1.1, v1.2, v1.3, v1.4, v1.5, v1.6, and v1.7. Okay, then I will download. Okay, so bit number 1 or byte number 2 is turned on. So bit number 2 turn on. If we would like to turn on all bits, we can write like this: 1 1 1, and then okay, it will turn on all bits. Yes. So the communication between PLC S7-300 Smart and PLC S7-300 is okay. Okay. So we can configure the PLC S7-300 and test also. Yes. Let's go to see the step 7 microwin. Yeah. I will use one more for step 7 microwin. Yeah. I will minimize this one first, and then go to another Windows. Yeah. And I will use step 7 microwin, and then first go to communication, because right now I will use PPI cable. Yeah, I already connected the PPI cable from my PC to the PLC S7-300 Smart. Sorry, 200. And this one should be get data from PLC S7-300 byte 1 bit 1. So it will start from V0.0 also, right? So I will use all the way on SM0.0. I will turn on the output. Sorry, insert one more for NO contact. So V0.0, and I will start the output Q0.0. Yeah, and let's test. Download. Yes. Okay, and then we can online, and I will minimize the window a little bit for easy to see the status. Okay, I will minimize like this. Okay, then I will online again. Okay, okay, we can online, and then I will go to the PLC S7-300. Yes, and minimize the window also, because right now I will use the false signal to see the status also. Yeah, so I will put like this. Okay, so it will start from, yes, SIMATIC, right? Start from IB200. Yes, so IB200, IB200, I will view as binary also. Yes, like this. And if I would like to turn on the bit number 1 of PLC S7-300, I can force. Yes, let's see, the PLC S7-300 is turned on for bit number 1. And if we would like to use another bit, we can use, okay, we can test Control V. One more, because I have 6 input for the CPU 222. So we copy, okay, and just change this one to V0.1, V0.2, V0.3, V0.4, and V0.5. Yeah, actually we can use until 6, 7, 8. Yes, V1.0. Yes, so this one should be Q 0.1, 0.2, 0.3, 0.4, 0.5. Yes, and then we can download for test. Okay, we can download. And then start the CPU back and then online. Okay, so I will for bit number 2. Let's see, bit number 2 is turned on. Bit number 3 turn on. Bit number 4 is turned on. Yeah. Bit number 5 is turned on. Yeah. Bit number 6 is turned on. Yeah. And then I will show the status of the PLC. The output is turned on. Yeah, right now. Yes. Let's see the status. The output is turned on for PLC S7-300 Smart. And for PLC S7-300 is turned on also. Yes. Okay. The network is linked properly. Okay. It means that the communication is okay between this network. So here is the node. Yeah. Let's see if we already download the program to the PLC after configure. Let's see, the data is linked. It will show like this. Yeah. And for S7-300, it will show like this. Yeah. It means that the communication is okay. Yes. So if we would like to send data from PLC S7-300 example to PLC S7-300, we can also do it. Yeah, I will command. So send data from PLC S7-300 to PLC S7-300. Yeah, by number 1 bit. Actually, this one bit number 1 to bit number 6, right? This one we can command bit number 1 to bit number 6 also, or bit number 8. Yeah. So for PLC S7-300, let's see here the hardware configuration. Yes, I will explain. Yes, let's see here the PLC S7-200 Profibus, right? So the data is start from 4 and then earn 5, right? So the V memory, it will adjust. So there are 2 bytes. So if we would like to send the data to the PLC S7-300, we can start from V 2.0, right? Because we use 2 bytes, 0, 1, and start number 2, right? Okay. So we can write V, or we can use always on first, SM 0.0, and start from V 2.0, right? Sorry, 2.0 is the output. Yeah. And for the input, we can use M 0.0. Yeah. Okay, and then we can download and test. Okay, download and test. And we can online. Yes. So we must write the logic also to get data from the PLC S7-200, right? So I will outline first. And insert the new network. So this one get data from PLC S7-200. By number 1, bit 1 to bit 6. Yeah. Okay. So we can use move. Yeah. Move IB4, right? Because the address is start from 4. Yes. Here. Start from 4 for input. Yeah, here. So we can use move IB4 to MB, example MB10. Yes. So we can insert the new network. So this one should be bit number 1. And then we will convert from byte to bit, right? So M 10.0. And this one, I would like to turn on the output of PLC S7-300. Yes, let's see the hardware for DO. It will start from DO, right? 136.0. Okay. So I want to turn on Q136.0. Then we can save the project and then download to the PLC and then online. Yes. So if I turn on from PLC S7-200, let's see, the PLC S7-300 is turned on also. Yeah, for bit number 1. And for bit number 2, we can also write. So we can copy. This one should be M0.1, V0.1. M0.2, V0.2, M0.3, V0.3, M0.4, V0.4, M0.5, V0.5, yeah, and you can use control key and a row key to connect. So this one should be .3, .4, .5, this one should be .2, .3, .4, and .5, and we can download. During download, it will stop the output of PLC. Yes. Continue on. And we can online. And for bit number 1, bit number 2, bit number 3 until bit number 6, we can also create it here. So I will insert the network. This one should be bit 2, right? So bit 2, it will start from M. Yeah, we can copy 10.1 to turn on the output. Q136.1. Insert the new network. And we can copy and paste. Number 2, this one should be Q136.2. This one should be .3. Insert .4, .5. Yes. So this one should be .3. This one should be .3 also. This one should be .4. This one should be .4 also. And the last one. Actually, we can use 8 bits also, yeah, but it's just example, so I will insert only 6 bits. Yeah. Okay. Then we can save the project and then download to the PLC and then online. Yes. So let's see here. If I turn on the bit number 2, let's see, bit number 2 is turned on, and I will show the status on PLC S7-300. Yes, let's see, the PLC S7-300 is turned on 2 bits of output. Yes. So if you would like to turn on bit number 3, you can turn on bit number 3. Yes, turn on. Bit number 4. Turn on. Bit number 5. Turn on. Sorry, bit number 4, why not on? Let me check. Bit number 6 is turned on, yes. Let me check why not on for bit number 4. Zero dot 1, 0.2, sorry, V 10.3, right? Why not on? Ten point 0, 10.1, 10.2, 10.3, 0.0, 0.1. Oh, this one should be 10.4, right? 10.3, 2.3, right? Sorry, I will change this one to V 2.3 and then download again. Yes. Okay. So let's see. The output is on. Yeah. For 6 bits. Yeah. So for PLC Smart, we do the same procedure. Yes. So let me minimize this one first, because we already tested. So let's go to PLC S7-300 Smart. So we need to send the data to PLC S7-300 also, right? Okay, so I will offline first and then command send the data from PLC, send the data from PLC S7-300 Smart to PLC S7-300. Yes. So for byte number 1, let's see the hardware configuration. Yes, I will explain more. This one it use 4 bytes, right? So the output will start from V 5.0. Sorry, 4.0, right? Because we use 4 bits, 4 bytes. Yes. So if we would like to send the data from PLC S7-300 Smart, we will start from V 0.4, right? Sorry, 4.0, right? So I will use SM 0.0 all the way on, and then this one should be M, example M 2.0. I will send M 2.0 to V, turn on V 4.0. Yes. Then we can download and test. Then we can online. So we need to create the data here also, right? So I will command get data from, I will zoom a little bit, yeah. PLC S7-300 Smart. Okay. So for byte number 1, yes, we can use move. So the address is start from 0, right? Okay, so I will move IB0, sorry, 0 to 3, right? This one, let me check. IB0, yes, it will start from IB0. Yes, IB0. And then this one we can convert to M. Yeah, example, I will use M20, MB20. Yes. And then we can convert to bit, right? So example bit number 1. Bit number 1 we can use 20.0, yeah, and start the output. Example, I will start the output to 37.0, yes. Then we can download, and then we can online, yes, and then like this. Okay. Okay, like this. So if we would like to for the signal, we can for on. Yes, let's see, the output is turned on. Yes. So the communication is okay. So another bit we can use the same as the instruction. Yeah. Example, the bit number 2 we can also use 0.m2.1, yeah, and then turn on v4.1, yes, and this one we can insert the new for network for bit number 2, yes, and we can use m20.1 and turn on the output q137.1, yes, and then we can download, we can online, and this one we can download also, and then we can online, and for the signal right on, let's see, the output is turned on and the PLC is turned on also. So let me show the status. Yes, let's see, the PLC is turned on, yeah, for Q137.0 and .1, yes. So the communication is okay between all PLC. The first one is PLC S7-300, the second one is PLC 200 Smart, and the third one is PLC S7-200, okay. So this is just example about how to link the data from PLC S7-300 to PLC S7-200 Smart and 200, yeah, by using the PROFIBUS-DP, okay. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And the benefit of this communication is we can use the less cable, yeah, we can use only one core of cable Profibus, so we can link many data that we want, okay. So I hope this video is useful for everyone, yes. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye.